بسم الله الرحمن الرحيم لإيلاف قريش إيلافهم رحلة الشتاء والصيف فليعبدوا رب هذا البيت الذي أطعمهم من جوع وآمنهم من خوف صدق الله العظيم.
صدق الله العظيم. صدق الله العظيم. Dr. Sadruddin, do you speak Arabic?
No, but I understand.
No, but your nice tilawa, it is properly Arabic letters pronunciation. Thank you very much. It's hard. Thank you.
Over to Dr. Abdul Ghafoor, and he will moderate today's program.
Thank you, Dr. Sadruddin. Bismillah ar-Rahman ar-Rahim. I'm Abdul Ghafoor. On behalf of comstech and IOFS, Islamic Organization for Food Security, I welcome all the excellencies and all the participants of this very important training workshop on acquisition, conservation, exchange, and safety duplication of plant genetic resources in OIC member countries for the Asian chapter. This is the second day of the workshop, and in this first session, this is second technical session, the first of today, but this the second technical session. We'll be having 5 presenters in this. One for gene bank consideration and requirement and challenges in gene banks and PGR management by Dr. Sadruddin Siddiqui. He is the director of BCI. Then Dr. Shakil Ahmed. He is the curator of plant gene bank. He will be talking on germ plant exploration, population assessment and collection. Then Dr. Amir Sultan. He is the in charge National Herbarium in Pakistan. He will be talking on importance of plant identification and herbarium specimen record preparation, all these activities. He will be talking on that. Then our colleague, our partners from Malaysia, Ms. Suryanti Pustam. If I don't spell rightly, please forgive. She will be talking on conservation of recalcitrant plant genetic resources and in vitro techniques for conservation of plant genetic resources. That is a very important topic on genetic resources. Then Mr. Muhammad Ismail, will be talking on intellectual property rights. Because intellectual property rights are very important for benefit sharing mechanism. Then in the last, we will be having discussion and conclusions. Dr. Ismail Abdul Hamid and Dr. Sadruddin will be assisting for all this discussion and conclusion. Then we'll be having a small documentary about comstech activity. Now, if you allow me, I will start with very good morning. Dr. Sadruddin, please.
Okay. Bismillah ar-Rahman ar-Rahim. As already told about my presentation, that I will talk on the requirements and challenges. So as far as yesterday's presentation that we have seen, it seems that most of the gene bank, they are at a very good position, and they might not require, they have already much better position than from those who want to start. There might be few gene banks that may need this information, but it is our aim to bring awareness for improvement. So I will start with this presentation. The current status of biodiversity is that more than 300,000 edible species and 7,000 species are used for human consumption. 400 plant species are domesticated, and 12 plant species contribute 75% of the 3 major are wheat, rice, and maize, contributing 60% of the calories and 56% of protein from plant sources. And about 20,000 plant species are used as medicinal and aromatic plants. 400 are used in Pakistan. And this diversity is declining and we want to conserve them. And for conservation, yesterday we have discussed how it should be done. So climate change is, and for soil different type, that salinity is there and other, we have to manage biodiversity. And already discussed the conservation strategy, we will discuss on the ex situ, particularly the seed gene bank and the safety duplication. So the nature of propagule from which the plant goes to next generation decides, and there are clonally propagated crops that will be taught by Malaysian resource person, and I will talk about the seed propagated plants, that is orthodox seed mainly. So when we say about orthodox seed, then there are two things mainly: the seed moisture content and the temperature, which make a difference. So at a higher temperature and moderate temperatures and higher seed moisture content, seed will germinate. And ultimately, if it is in stored condition, it will die. And if we, at high moisture content, keep the material at very low temperatures, -20 and -10, it will have freeze injury. And at about 20% seed moisture content and higher temperatures of storage, there will be problems of fungi, mites, and bacteria. And above 10% seed moisture content and in a range of storage for 10 to 35, you will have insect problem. So the safe limit is that 10% seed moisture content, if we keep and the environment is the same, we can avoid all these same these problems. So this is the target, that seed moisture content should not exceed more than 10% when we are talking about storage. So at 10 degrees centigrade, we can safely for 20 to 25 years conserve, and at 0 to 5 degree, 50 years, and at -20, 100 years plus. So we start doing the work of conservation of seed and gene bank. But the problems arise, number one, is the person who is leading is not a gene bank manager and has no training on the management. So all the decision will go wrong and there will be many problems. Similarly, human resource division, development, the recalcitrant seeds are collected and conserved just like orthodox seeds. So this is the problem of because it has no training. So all the seed that are orthodox, they will be of no value, and the recalcitrant seed will die off very soon. So consensus on the activities that has been planned, it should be done with the technical collaboration and with the knowledge, and should not be changed often, because it will cause problem if you change something in the midway. For example, the accession number, you allot a sequence and then you change, then the new numbers and the old numbers, they will confuse. Similarly, about the policies and other things, you should develop a consensus first and then start the business. The SOPs should be developed sequentially. All the flow chart of the mechanism should be outlined, and then the work should be assigned to the staff, that who will do the work, what will be the work done, and how and where. All these should be defined. Regarding facilities, we should take care about and consider all the possible facilities that we can provide. For example, multiplication of cross-pollinated crops is a problem in open field. So you can develop the screen houses for that. But if you don't have screen houses, of course, you have to go for bagging of the for controlled pollination. The multiple crop passport descriptors, they are important to have the information about the material that we have stored in the gene bank. And there are many of them. Could be about 35 descriptors or 40 descriptors. So you can add whatever you want, but adding it after you have developed the database, it is very difficult and causes problem. So whatever you can think of, you should in the first time develop all the MCPD and then start your data recording. Of course, improvement when you require something more data, like before we have only accession number, but now the gene banks are going like the digital object identifiers, the permanent unique identifiers number are being given, just like for publications we have. So we have to upgrade to that. That's another thing. But initially, we should make maximum possible that whatever descriptors that we will be needing for our data recording and for representing our accessions properly, we should do it. And work for quality assurance. That is PGR after multiplication sometimes are not channelized with quality assurance. They said we are multiplying in our location, so it's already, we are taking for granted that we are doing quality work. But quality becomes compromised when we don't follow the SOPs. So within the country, there may be different stakeholders that are maintaining the gene banks or genetic resources. So they must be linked together. So there are problems in linking up the different stakeholders. Similarly, many treaties are signed, but there is no capacity building or implementation, that how the PGR will go into the multilateral system, how the access and benefits will be, sharing system will be adopted, and what legal procedures would be adopted for that. Similarly, the material will be shared by signing SMTA, how it will be reported. So complete training and human resource development is required for that. And most commodity programs, they work on a single crop or a group of crop. For example, for cereals, they will be working on 5 or 6 species, but the gene bank has to work on numerous species, like 175 or 350. So it's very difficult to develop the calendar for their regeneration and multiplication. So human resource is always scarce in gene bank, and not much universities, they offer courses that lead to such kind of profession. So it is a problem. So with consideration, the main philosophy in keeping the material in gene bank, that it has to maintain the viability and the genetic integrity. So these are the two main considerations that should be with the material in the gene bank, and already told that seed master content and temperature has to be manipulated for achieving this. But besides this, there has to be awareness about the importance of PGR to all the stakeholders, including the financial managers and the policy managers. Otherwise, it will be difficult to get funds and proper policies for conservation and distribution and utilization of the genetic resources conserved, and they will be just conserved and wasted and not used properly. So there has to be an assessment of the need, how much PGR we have available and how much we have to conserve, and we have to come to a conclusion for how much the target we should set, 100,000, 200,000, because if we don't have much diversity, like in some countries, the area is small and the conditions are desert-like and there is not much vegetation. So if they have about 1,000 accessions, different complete, or 10,000 accession, so they should not think for conserving a very huge number like 200 or 300,000. And the categorization of the seed for orthodox seed, recalcitrant seed, vegetatively propagated seed, heterozygous material, trees, they have to be treated differently. So when you are defining or trying to build up these facilities, you should give consideration. So for orthodox seed, the consideration that seed should be untreated and high quality seed with maximum viability more than 85% viability, and minimum 2,000 for self-pollinated and 4,000 for cross-pollinated. But other literature also suggests that this is the minimum, but 3,000 to 4,000 seed for self-pollinated and up to 12,000 seed for cross-pollinated should be conserved. Seed moisture content should be 3 to 8%. The more negative we go below zero, the more lower seed moisture content is better. So seed storage temperature minus 80 degrees centigrade for long term and plus 4 degrees centigrade for medium term. So this is the minimum requirement. You can even keep the working sample at 0 degrees centigrade. So monitoring of viability after 10 years for long term and 5 years for medium term storage cycles, and regeneration with 100 or more plants to avoid loss of allele. So the consideration will be how much material you have to conserve, how many funds are available, technical know-how, and availability of materials and equipment, whether it is local or imported. And you have to see the best option as well. So local is more important because it will be easy to maintain. It will be more sustainable as compared to imported material. But if you have no choice, then you have to work with the imported material. So I have visited few gene banks, and while I was visiting the Millennium Seed Bank in UK, so there I learned that although it's an advanced country, but they were using the cooling the compressors from the Austrian company because this is the best. And the Chinese gene bank is also using that same system, and it is very energy efficient. In Pakistan, the cooling unit compressor we are using system, it takes about 10 kilowatt electricity for a small unit. And MSB system was a very large storage capacity, and they are only using 1 kilowatt per hour electricity. So it's very efficient system. So we should shift to efficient system to save energy and increase the performance and efficiency. So awareness of gene bank operations and management should be to each person who is involved in the gene bank activity. And best is to visit gene banks in detail with technical teams so that we can encompass what are the how the construction is and how the facility is established and what are the linkages, how to set up a system. So for site selection, it should be a socially stable area with security and reliability of electric supply and fluctuation, and suitable substratum for foundation and adequate drainage and absence of flooding. Situation from, it should be away from any dangerous chemicals, fuel storage area or something, because it can cause hazard. In case of fire, the gene bank may be damaged. And easy access to area where seed and active collection, threshing, these are all performed. This is from the PGR book. And the main building should be earthproof. And if there are more earthquakes in that area, it should only be a single-story building. The core main storage should have racks and shelf and the type of compactum type, which can be mobile. If you are making stationary, it will take too much area. So the ancillary facilities should be arranged in a way that the most common practices are arranged at a place, and those performance which are not directly related to seed banking, they can be performed at a different site. For example, the seed processing, seed cleaning, seed viability, and dry room, they should be nearby to the gene bank. And evaluation lab, data management lab can be placed far away, no problem. So we have to consider all the activities and then plan accordingly. This is just a comparison of mobile shelves with the static shelves, so you can double the space for conservation by using mobile shelving. So National Gene Bank of Pakistan has all the laboratories arranged accordingly, and all the mechanism, the gene bank operation has been outlined right from introduction and collection to viability monitoring and regeneration and multiplication. So whether you are keeping the material in the gene bank in a very sealed containers like aluminum foils or double cap bottles with a push cap and a screw cap, and also putting some silica gel inside so that the moisture, if any taken inside, could be absorbed if the cap was little loose. So that will decide what would be the ambient condition in the storage condition. So most people keep in a cloth bags, the seal, and some keep in the tight jars. So relative humidity should be not more than 45% in any case in that. But if you are keeping material in cloth bags, then you have to maintain the humidity to about 10% or something like, and that will be very expensive. So the cooling and dehumidification unit should be efficient. The installation should be 3 to 4 inch between the walls and of the material that does not take the insect or fungal infection or something. There should be airlock or buffer rooms between two different partitions or storage conditions, and minimum ductings and minimum in-out movement procedures should be adopted, and efficient workflow, as already I mentioned. So there should be at least 2 units of refrigerant system in each room, so that if there is some damage or malfunctioning in one unit, the other is working. And the refrigerated coolant gas that has been used, it should be something that is locally available. For example, in Pakistan, the coolant gas that is being used in -80, it is not available. So if we use that material and if there is a leakage, it will be very difficult for us, rather not possible for us to replace the -180 system. So we have to work with -20 in general. More, it is logical and feasible. Although we want to work with -180 storage, but we have this problem. So one has to see is local conditions, what is available and what is not available, and what could go into problem in future. So -80 storage incubators are very expensive. And if we bring and there is some leakage, it will be useless for us. So the backup power should be available, and especially if you have solar energy, it's more better. There should be sufficient air circulation between the cooling chambers. 2 degrees plus minus is okay, but if you have blocked with some permanent structures, the movement from the main air conditioner, it will be a problem, and it will be too much difference between the different sections of the cold storage room. So temperature and relatively monitoring devices should be there, and safety provisions should be, including the safety of the doors that can be opened from inside in case of emergency. So there are different type of storage conditions like walk-in store that I am talking about, and there are incubators, low temperature, and freezers. So depending upon how much material that you have to conserve, you have to decide. And the safety duplication should be in sub-zero temperatures in all cases and a different location. So capacity and targets, as I've already discussed, that you should know what you will be collecting, how much you will be collecting after the capacity, and then funding should be from some core budget from the government side and not rely totally on the projects, because projects end and all the activity stops. So how many human resource you have, scientists, technicians, drivers, vehicles for movement, they all will contribute toward your performance. Documentation is a very important thing, how that we come to know what one has and how valuable this material is. The quality of information should be there, should be precise and complete, and the accessibility, how data can be shared and we can obtain the information, and the presentation form, the database system, and how information is summarized, etc. So there is FAO has worked on the standard of the gene banks, so you can take help from that. You can search on the net. You can find other resources as well from different international gene banks that they have managed. So you can follow that standards which are already existing, but should you modify or should you define your own, it depends upon the capacity and training of your human resource. So there are many challenges in collection. First, we have to know what we are collecting, should have all the information about that. about its biology, its morphology, its phenological cycle, that when we go there, what stage it will be. It will be flowering stage or seed would be there. So some pre-assessments are made, and then the collections expeditions are made. So seed cleaning could be a problem, and I think these will be dealt by Dr. Shakil later on. So I will skip that and go to storage. So already discussed about the electric failures and temperature, humidity fluctuations due to some outside conditions, and some mismanagement or misoperations, like keeping the door open for very long time and coming out and from cold room often. And there could be rodent problems in the ducts too. They can come inside and damage the bottles. And sample size is large. Its handling and zero-based management is also an issue. So germination is defined differently for physiologists, but seed technologists, there has to be a healthy plant developed from the seed with normal shoot and root. So only that we consider, and it's a very experience to define which are strong and weak and abnormal in different case. So regeneration and multiplication is that we are dealing with different species. For example, in Pakistan, we have 350 species of different diverse ecologies and origin. So we cannot multiply them at one place. For example, even chickpea, if we try to multiply in Islamabad at our center, it's a hot spot for the blight. So we will not get any seed. So we have to go to other place. And for that, you need to have collaboration. It is very lucky for us that PRC has throughout Pakistan about 26 different stations, right from sea level to a mountainous area. So we can collaborate with them for different multiplication and regeneration of material. And for we have developed some isolation cages to multiply the material, which is cross-pollinated. And we do the bagging also, but it may not work all the time. Labeling is one thing. All the material, right from collection, from seed processing and viability testing, and then harvesting, and again processing. If label is one missed, all the sequence will go wrong. So it is very crucial that much care is taken for labeling. And it's better to go for barcoding and auto labeling print system, which can minimize this label issue. So financial resources are required, as already told, database. First, we were using Excel. So to develop our own and upgrade later with the time, it was very complex thing. So we opted to use an open source, Grain Global. And we are now shifting our data to that. And policy issues are there, restrict mobility and situation. We have to take consideration. Safety duplication. War have destroyed many gene banks. The National Gene Bank of Philippines was damaged by flood once and later destroyed by fire. So we have to take care about the safety of the gene bank and the staff all. And seed bank of Afghanistan, Syria are completely destroyed by war. So safety duplication is very important. And the purpose of this this training workshop is also that we come up with a solution within the OIC countries. And the standard operating system, SOPs, these are the written instructions which I talked about. They bring uniformity in performance and improve the function, that who will do what and when, and it is ensured that everyone follow those SOPs and do consistently the same work. So even a new worker will come, they will come to the same quality, and we will not waste the time and have to do reworking. So recording the evidence is very important. All the materials working that we are doing, logbooks, that should be maintained. And there are different type of documents and things, including maps and surveys, equipment, policies record, import permit, these all you, and the database that you are maintaining, it's all part of recorded evidence that what work you have done, we can check it and it will be authenticated. So this will bring the work to quality assurance, and the most element for quality management is that we should adhere to the standards, treaties, and agreements, do the documentation, and develop an audit and review system for continual improvement of the plan. Just identify the things and then compare the result, analyze and improve, and keep this process on. So maintaining biodiversity for sustainable agriculture for food security is the main target. Digital networking for PGR stakeholders and sharing of information among the OIC member states we should do, and make joint ventures for utilization, evaluation, and gene bank management, develop human resource, do exchange and trainings, make regional teams, and work together to achieve the PGR conservation through seed banking and safety duplication. Thank you.
Thank you, Dr. Sadruddin Siddiqui. You know, it was a very long topic, and thank you not taking much more time, just 5 minutes, you took more. For next presenters, it's the request that the time is 20 minutes. Try to complete in 20 minutes. Our next speaker is Dr. Shakil Ahmed from Plant Genetic Resources Program, BCI, National Agriculture Center. He will be talking on germplasm exploration, population assessment, and collection of plant genetic resources. Dr. Shakil Ahmed, please.
Bismillahirrahmanirrahim. So I will talk about germplasm exploration, population assessment, and collection. So this presentation is in gene bank perspective, and seed bank. We know that seed banking is a complex system that needs great care and substantial resources. So we know that green revolution in 1960s accelerated the replacement of diverse traditional crop types by few number of uniform modern varieties, and this necessitated the need to establish gene banks and conserve maximum diversity. So in this perspective, exploration and collection in the is a major and very important source of germplasm acquisition. So if more diversity is conserved and available for future use, the better the chances of fulfilling future demand. So reasons for collecting can be categorized into conservation-based and non-conservation based. So in this case, for the gene banks, it's the main reason to capture maximum diversity, and similarly gap filling in the gene banks and rescue collecting, for example, like Atatürk Dam was constructed in Turkey, and before that, the whole area was collected for all available species. The rest of the three can be non-conservation based according to need of breeders, or maybe international or national demands, or focusing some research purposes. The collection mission can be categorized into multi-species versus species-specific, wild species versus crop collecting, and single visit versus multiple visits. So in case of multi-species visit, it means it is targeted origin where all possible species are normally collected. Whereas in case of some species, so there is no region specific, we need to move all available source where we can find that species. And single visit versus multiple visit. So in this case, most of the crop varieties, it's not possible to get their seeds in single visit. And for maybe crop collecting, we can take seed in one visit. So in case of maps and CWRs, we need to have multiple visits, maybe pre-assessment visits and countries. So germ plant collecting is an expensive task, and we are most of the time facing scarcity of funds. So there is we need to have clear justification for any product expedition mission, and comprehensive and well-planned expedition can be a very helpful collecting a lot of germ plant in limited time. So before planning collection and expedition mission, we need to have several considerations in our mind. For example, what is the objective of this mission? Is it pre-assessment or collection mission? What is the target species we are going to explore? And do we have enough information of that target species or region we are traveling to? Do we have appropriate staff to deal with post-collection seed handling in field? Do we know how to check the quality of material in the field? So we need to have important consideration. For example, we need to prepare our species, target species list. For example, in case of maps, we have prepared 100 plant species that we need to explore. Similarly, we need to have potential collaborators. We already prepared that kind of list. Similarly, we need to prepare collection guide that should be having all available information about those species. And for the collection of that species, we need to have strong strategy. For example, easy access to region, safety and security situation, climatic conditions, contact with collaborators and logistics, etc. So the best way is to develop our own collection guide, like we have prepared for medicinal and aromatic plants. So this is just for example. So those collection guides should contain species description, information of the location of those species, images and mapping, and phenology information, conservation assessment, habitat distribution, and taxonomy information. This is a simple page from that guide that is showing name of species, description of the species, illustration, and herbarium voucher, and conservation assessment, as well as phenology of that species. So we have prepared target species, we have list of collaborators, we have production guide, and we also have done mapping. But still one important aspect is missing, that is of great help in the collections. Like in this case, we have divided the country into 10 zones. So you can see the list of species at left side and explanation of those zones in the right side. So we have categorized all those species according to occurrence in the zone, according to their flowering and maturity time. So in this way, we can better manage our collection expeditions. So with all this exercise, we are now able to decide what to collect, where to collect, when to collect, and how to collect. So resources we need, there should be an appropriate team. It shouldn't be not only few persons or not too many persons. So good quality vehicle, depending upon the region, if we are going to mountainous regions, then we should be having some 4x4 Jeep. And in plain areas, we can use double cabin and other vehicles. Seed collecting kit, and we should also have some temporary storage facility during the trip. And we should also have initial assessment. So is the region safe for travel? Do we need to get permission to collect seed plant material? Are there any high-risk pests or pathogens that could restrict plant collecting in this region? which organization should be invited to participate in the seed collecting program, and what kind of skill and expertise could they bring to the work. So as I already talked about multiple visits, so why pre-assessment visit? Through pre-assessment visit, we can get initial information about those species, about its flowering time. So like in this case, we visited northern Pakistan, and for that particular species of Sisal, we found the location of their population. So we identified the plant at this stage and visited later on to collect the seed. Same is case for the Icomia. So because at flowering stage we can identify like these two species, but at seeding stage it's not possible to identify. Similarly, it's difficult to identify between some species of the same genus, like we can see here Aconitum species, we can identify at flowering stage, but not at seeding stage. The same is case with Toxicum species. So right team is also necessary for, so we should not go like this. We should be having a few numbers that can do a perfect work. So normally 3 to 4% team, depending upon situation, is suitable. So do we have everything we need during expedition? So this is the kind of checklist we need to show, like permission letters. These are needed to proceed for collection. So navigation, maps, and itinerary GPS we should be having. First aid and safety, at least one person, if preferable, should be about first aider. So for plant identification, we should be having a collection guide. If we have taxonomy, that is the best. So collecting and labeling, so we should be having jeweler's bags, tag, and bag other stuff. Herbarium specimen preparations, we should be having press and paper. And for data recording, we should be having standard recording sheets. So targets and priority list we should be having with us. So this is all stuff that should be carried during a collection and expedition mission. So once we reach at the collection site, there we decide about the population. So we need to find some vintage point, and then we can decide how many mature plants are there, and if those plants are sufficient to sample seed from those one. If we found so many plants that can be collect seed from them, then we can proceed for next step of collecting seeds and preparing specimen and others. And also we need to distribute responsibilities, like some person may collect. One can assess the seed quality, physical as well as physiological, preparation of herbarium vouchers, and information gathering. So once we have reached, so we need to test seed quality in two ways. One is physiological seed quality and other the physical quality. And at that time we can also decide how many seed we can collect. So physiological state we can assess from its indicators like change in fruit color, change in seed coat color, fruit splitting or breaking open, seed rattling, seeds that are hard and dry, and some seeds are already dispersed. And for the physical state, we need to be careful not to collect insect damage seeds, empty seeds, or badly formed seeds. So we can later on also judge this through X-ray. And in the field, we can do this with the cut testing. So this is a field data form we normally use in the field. It contains information about the collectors, collection date, accession numbers, their affiliation institutes, and information regarding state of plant population at collection site, about the country, location coordinates, and soil type, and similarly plant habitat and threats to the population. So all this data we gather in that form. So at collection site, depending upon the nature of plant, we do stripping in grasses, plucking larger fruits, pruning, and in successful time we use long cord to harvest seed, and simply through shaking we can also collect the seeds. So in field we also need some initial drying, and different method can be used. However, we need to keep in mind ambient humidity must be lower than the moisture status of that seed. If the ambient humidity increases, the seed should be protected from that situation. Preferably shade the seeds from direct sunlight to reduce excessive heat. So we can also use different desiccants in the field drying. So blue drum silica gel is also suitable to carry with the collection team. So in some cases, fruits are not completely ripened, so we can collect at immature stage, like you can see in this Sansevieria species. So after 4 weeks at 20 degree, they were completely ripened and the seed was then extracted from this. So premature extraction of seeds and rapid drying leads to poor seed quality, as seeds may not develop desiccation tolerance or may not have fully formed. So continued maturation of seeds inside fruit is possible. So keep attached to stem or branches. Mimicking ambient conditions seems to give best result also. So in case of some species, like dealing with fleshy fruits, so in this case, remove the seeds from fleshy fruits as soon as morphological signs indicate that they are fully ripe. So once remove dry seeds from fleshy fruits slowly under ambient conditions. So key points in all this process we need to have: initial quality has a significant impact on seed longevity. Maximum storage potential occurs around natural dispersal. Using knowledge of seed moisture status and ambient conditions to best handle fully ripe seeds. So premature extraction and rapid drying of immature seeds leads to poor seed quality, and fleshy fruit should be processed as soon as they appear ripe. So monitor seed moisture status, and in the field we can use different weather apps. We need to have power banks in remote areas, and PDF map also facilitate us in remote regions. So seed bank management, we can see start from collecting, seed processing, storage and duplication, and mobility monitoring, and then data management and finally distribution. So thank you.
Thank you, Dr. Shakil Ahmed. Dr. Shakil was talking on the plant distribution, population assessment, and collection. It was really very comprehensive talk on this very important topic. Our next speaker will be Dr. Abid Sultan. He is from National Herbarium, NARC, Islamabad. He will be talking on importance of plant identification and herbarium specimen record and preparation. You know, accompanying taxonomist is very important for collection of, especially for crop-wide relatives and other special crop species. Dr. Amir Sultan, please.
Thanks, Dr. Abdul for a generous introduction earlier on. I will be talking about importance of plant identification and importance of herbaria, as well as how to prepare herbarium specimen for the sake of proper identification. In general, herbaria or herbarium specimens are useful as reference material for plant identification, for determination of plant locations, ranges, abundance, habitat, their phenology, and they provide baseline information for publication of monographs and floras, regional floras. Plant systematics is the core research emphasis for herbaria, which comprises 4 main areas: taxonomy, the recognition and formal description of taxa, nomenclature, phylogeny, and classification. and the results of systematic research help us better understand plant identities and their relationships. Herbarium specimens are also useful in different disciplines, like in agronomy and forestry, to locate wild plants that have potential as new crops, document plants used as crops and forage, locate and identify relatives of cultivated species for use in breeding programs, identify and document the spread of weeds. Herbarium specimens can also prove useful in anthropological and archaeological studies. For example, if you want to identify seed, wood, and other plant materials from archaeological sites and document plants used by earlier people or people or in different communities. Herbarium specimens can also be used to locate and document plant communities of individual species and identify and document invasive species. And in environmental regulation, to identify plants in an area in order to define the habitat and designate an environmentally and legally appropriate use of the site. In entomology, the herbarium specimen can help locate food plants and habitats of insects and document pollination ecology. And in case of horticulture, herbaria can help identify native and cultivated plants and plant varieties and cultivars. These are examples of some wild ornamental flora from Pakistan. In forensics, can you get rid of those bars above? Thank you. Identify plant fragments that might yield evidence in legal cases. So it has used herbaria have used in forensics, history, pharmaceutical research, poison control and medical care, veterinary science, and even in zoology to identify animal food plants and locate animal habitats. This is a summary of world's largest herbaria and the number of specimens they hold. So, Natural History Museum of France has the largest number of specimens. Something about plant biodiversity of Pakistan. Pakistan has a rich and varied flora. There are about 6,000 species of flowering plants found in a variety of habitats, from seashore to deserts and high mountainous areas in the north. And there are about 463 endemic species in 175 genera and 43 families. Pakistan lies at the juncture of 4 phytogeographical regions that are Saharo-Sindhian, Irano-Turanian, Sino-Japanese, and Indian phytogeographical region. Can't move to the next slide. Yeah, thank you. A brief introduction about National Herbarium of Pakistan. It was established by Dr. Reynolds Ralph Stewart at Gordon College, and from 1912 to 1959 he has been collecting extensively in Northwest Himalayas, Western Tibet, Kashmir, Kuram Valley, and Balochistan. And National Herbarium of Pakistan now has a collection of 100,000 specimens, including about 150 type specimens, and it houses about 12,000 species from the region. Something about Flora of Pakistan. First volume of Flora of Pakistan was published in 1970, and over the last 5 decades, 224 volumes on Flora of Pakistan have been published. Each volume has identification keys, detailed descriptions, illustrations of selected taxa, as well as information on their botany. E-version of these different volumes of Flora of Pakistan is also available on the web. XC2 conservation at Botanical Conservatory. National Herbarium launched Botanical Conservatory back in March 2016, and we have live collections of over 250 native plants, which include narrow endemics, rare native plants, as well as medicinal and biodegradable plants. These are some examples of endemic plants which are being conserved in the Botanical Conservatory. This is Nipitagripphicae from Malakand, Rauwolfia serpentina, and Rubia tortuosa. This is a genus which is endemic to Pakistan. Buxus papilosa. This is an aerial view of the botanical conservatory. A case study on why it is important to properly identify a plant and how to collect plants for proper identification and process, how to process specimens and identification. So this is what I am going to be talking about in the second part of the presentation. So why proper identification? Use of exact plants is necessary to ensure the quality of herbal drugs, because in most cases medicinal plants, medicinal herbs are knowingly or unknowingly substituted or adulterated with similar species or varieties. Use of a wrong herb may be ineffective or in some cases even fatal. A case study, the butagroviolens, which is also called sadab, is an important herb known to have anti-inflammatory, antiviral and other properties. Seeds of sadab or the butagroviolens were bought from different herbal medicine stores in Islamabad and Rawalpindi. And seeds readily germinated, and when plants flowered, they were uprooted and identified as Euphorbia dracunculoides. So the seed available in market was not actually butagroviolens. Euphorbia dracunculoides was being used to adulterate or being sold as another species. Other studies also show that this plant is often used as an adulterant with glue, and its use can be dangerous as the adverse effects of Euphorbia dracunculoides include nausea and vomiting. Collecting specimens, this is a glimpse of gadgets that we need when we embark on a collection trip. We use secateurs, pre-pole cutters, newspapers for retaining each plant through the drying process, drying paper, press frames and press straps, a GPS, a camera. Corrugated sheets help speed up the drying of specimens by ventilating the press and conducting heat. Tissue or thin paper for protecting delicate flowers. Flowers can be used, and paper or mesh bag for carpological materials can be used. Plastic bottles for separate organs and portions into liquid preservatives, and feedstock and fuel for heat drying for presses can be placed over frames, especially in humid climatic conditions. And stoves placed underneath, then presses are covered with fireproof curtains. Color photograph in the field is very important in order to record flower color and habit as well as habitat. Sometimes we need to collect subterranean parts also, the underground parts, to show the if it possesses a rhizome, a bulb, or a core. So a good collection should always comprise adequate samples of all organs available at all stages of development. Ideally, flowers, fruits, foliage, and subterranean plant parts should be collected. For herbaceous plants, it is important to collect subterranean plant parts as well. Large plants often need to be bent into a V or N shape in order to preserve all diagnostic characters. Each collection is assigned a collector number, which is written on a paper tape tied to the specimen. This is, as already talked about by Dr. Shakil, this is a summary of collecting information that we need. So this is a minimal information that we record. Some glimpses from the field while collecting. So once the field data has been recorded, specimen is pressed in layers of newspapers along with blotting paper in a field press. Blotters change on a daily basis until the plants are thoroughly dried. And once the plants are dry, these are packed in large plastic bags, sealing off the ends with the sellotape. These are then frozen for 3 weeks to check any insect infestation. And after 3 weeks of exposure to low temperature, the packet is allowed to come to room temperature and then opened. Once the plant has been identified, it is databased and is then poisoned with a 3% accusation of sodium pentachlorophenate and then dried. Specimens are then mounted on standard weathering sheets using acid-free glue. Robust specimens are sometimes stitched to the bedding using a needle. Label depicting collection information is pasted to the bottom right of the bedding sheet. The specimens are then ready to be moved to species folders in the main bedding collection. For further reading, I would suggest this important book, the Heavy Handbook, edited by Diane Whitson and Leonard Foreman. For identification of specimens in Pakistan, we use different volumes of Flora of Pakistan, Flora danica, Flora of China, and other species genetic monographs. A remark by Ian Hedge from RPG Edinburgh: taxonomists are an endangered species. More funding is going into molecular studies, and it is very difficult to get funding for jobs in taxonomy. Yet taxonomy is so important in any botanical research, even at a molecular level. The whole thing is worthless unless you have the correct name for the plant. It is also vital for conservation. If we don't know what a plant is, how can we conserve it? Thank you.
Thank you, Dr. Amir Sultan, for this very nice presentation. You know, taxonomy is a very dry subject, and it's the word endangered was devised by the taxonomists, and unluckily, you know, the taxonomists are going to be endangered. We hope the best for taxonomists. Yeah, please. Thank you. Our next speaker is Ms. Suryanti Rustam from Malaysia, from Agrobiodiversity and Environment Research Center, My Gene Bank Complex, Mardi, Malaysia. You know, Malaysia is one of the hotspots for
Hello.
Yeah, please. She will be talking about conservation of recalcitrant plant genetic resources. It is very difficult class of genetic resources and in vitro technique for conservation of plant genetic resources. Madam, please. Over to you.
Okay. Can you hear me?
Yeah, please.
Okay. Let me share to you my slide first. Okay. Thank you, Dr. Abdul Ghaffur, for the general introductions. Assalamualaikum and good day to all resource experts, participants and training secretariat. Okay, so the title that have given to me is recalcitrant species and in vitro techniques for conservation of plant genetic resources. So for this topic, I will be talking firstly about the recalcitrant plant genetic resources, and secondly about the method to conserve the recalcitrant plant genetic resources, which are through in situ and ex situ field germplasm and in vitro conservation. Under in vitro conservation, there are three techniques that can be used, which are normal growing conditions, limitation, or also known as slow growing conditions, or in a suspended growing condition, which is also known as conservations, cryopreservation, sorry. So my talk will be more on what Marie has been doing as the effort of conserving the plant genetic resources with the recalcitrant seed species. So what is recalcitrant seed? Recalcitrant seed is seeds which are normally shed at high water content. They remain moist, no substantial development arrest, and they maintain metabolically active throughout the development to the time of shedding. So they are normally desiccation sensitive and can adversely affected by even a mild dehydration, even at high moisture content, for example, 20 to 30% of moisture content. So they cannot be stored in a conventional seed bank because they are because they cannot survive after drying, and also they cannot survive in a low temperature like orthodox seed does. So recalcitrant seeds possible to be stored, but in a hydrated form and also in a temperature low enough to stop germination and to avoid chilling injury and also microbial growth. Normally at temperature higher than 15 degrees Celsius. So at this condition, normally they can be applied only for a short-term storage for several months, and we cannot expect it to be stored for more than a year. So why is it important to conserve the recalcitrant seeds, PGR? Because there are numbers of recalcitrant seed trees that we are using in our daily life as a food source, as a oil source, as a commercial use like timber and rubber, and also as a carbon capture. So we need to conserve as much as their gene pool, like as mentioned by Dr. Sadar yesterday. Monocropping is risky as plants are exposed to loss easily by disease or by the natural disaster. So normally this for long-term conservation, field germplasm is normally being used for the recalcitrant plant genetic resources. It could be in situ or ex situ. Through this method, the plant genetic resources are kept as live plant that undergo continuous growth and require continuous maintenance. This method are also can be used to conserve the species with which is not forming seeds, also reproduce or species that reproduce vegetatively, and also for the species that seed production takes many years. In Mardi, efforts in conserving recalcitrant PGR has been initiated for more than 30 years ago. This is listed here is the most recent research project related to recalcitrant and vegetatively propagated species in Mardi. There are projects with UNEP and JEF coordinated by Biodiversity International in 2009 and 2014 on the cultivated and wild tropical food diversity. Secondly, Malaysia Tech Development Fund 2011 and 15 on the development of plant cryopreservation and in vitro laboratory in Mardi, and Malaysia 11th Development Fund 2016 and 2020 on the underutilized fruit and product development for food in Mangifera odorata and Lepidopteris. And then Malaysian 11th Development Fund 2016 and 2020 on the potential traditional vegetables on Solanum melongena and Colocasia esculenta. And we also have a project with crop funded by Global Crop Diversity Trust and managed by Millennium Seed Bank Partnership on the crop wild relative in 2016 and 2018. On the banana, solanum, ipomea, and rice. And recently we have project with PSF, ITPGRF FAO, 2019 until 2020 on the conservation and sustainable utilization of the underutilized taro, which is Colocasia esculenta. So activities listed below are the activities related to the conservation of recalcitrant PGR in Mardi. So we are doing the inventory and survey in the selected sites. We are doing a collection of genetic resources. After that, we identify and characterize the species. We also produce the herbarium voucher, and we have a herbarium library. We also doing the genetic diversity analysis. We also have a team to to do the phytochemical and nutritional analysis of our PGR. And we do on-farm and in-situ conservation, and also we have ex-situ conservation, which is known as field gene bank. This is one of the example of on-farm, or also known as in-situ conservation by Mardi under the UNEC and JEF project, coordinated regionally by the Biodiversity International. One of the project aims is to encourage farmers to conserve PGR in their home garden. From this project, fruit catalog, which contain details information of plant species planted in their home garden of several farmers in 6 selected districts in Malaysia, has been published. So this is the layout of the inside the fruit catalog. So from our collection work, we have identified several elite accession of the rare fruit, which we have selected based on their taste, nutritional content, and fruits quality. For example, for Mangifera odorata, our elite accession of Lepidopteris fruticosa. And this is the picture of the diversity of wild durian that have been collected by our team, and we have conserved them in our field germplasm. So the map showing the location of our field gene bank all around Malaysia. The reason why we have several different locations for the field gene bank is because the suitability of the location for the PGR to grow, and also to have the duplication of our germplasms. So our germplasms covers the total areas of 119.1 hectare, which conserve total of 170 species and 3,087 accession of recalcitrant PGR. So this is the picture of our field gene bank in different districts in Serdang, Jelebu, Sintok, Jerangau, and Bintulu. So they have different type of species and rare fruits. So we all know that field gene bank is the common method for conserving the recalcitrant seed species. However, it has its own challenges, which requires a lot of space. It requires high maintenance and labor cost. It threatens to the natural calamities and adverse environmental conditions such as drought, flood, pest, and disease incidents, and it also exposed to loss due to land conversion. So this is the real situation that we have faced here in Malaysia. Our 30 years old collection in field gene PGR in field gene bank has been lost due to the land development. So this is the picture during 2008 and also 2018. So thus we can consider to conserve our recalcitrant PGR through another method, which is also known as in situ in vitro conservation. Not saying to substitute this method with the field germplasm, but as a backup to complement the field germplasm from losses. So in vitro conservation. In vitro conservation is a maintenance of germplasm in a relatively stable form under more or less defined condition under a controlled environment. We can also known as tissue culture. So the basic objective should be minimize the demand and risk of subculturing, and to stabilize the cultures in terms of genetic characters. So there are two approaches for in vitro conservation, which are germplasm in a growing state or germplasm under the suspended growth. So in a growing state, there are two types, which is germplasm under germplasm under, I cannot see the slide, sorry. Germplasm under growing condition and under the slow growth condition. For germplasm under the suspended growth, we can do it through cryopreservation. So this is the example of in vitro conservation in Mardi, which we maintain under the normal growing condition. We have 16 aroid accession from 2 species, which is Colocasia esculenta and Xanthosoma species, has been duplicated in vitro as a backup to the field germplasm. For this purpose, we need to have the tissue culture facilities like plant tissue culture rooms, tissue culture grow room, preparation area to prepare media and samples, and the disinfectant, cleaning and disinfectant area. As for in vitro conservation, which maintain under growth limitation condition, the aim is to reduce the requirement of subculturing. This can be done by the maintenance under the reduced temperature and reduced light intensity, the use of growth retardant, use of minimal growth media. We can reduce the oxygen concentration in the culture, and also we can use the osmotic regulators, for example, mannitol and sorbitol. If this type of condition, actually the aim is to slow down the growth of the media, the growth of the plant in the tissue culture. So this is the example of in vitro slow growth study in Mardi, where we add sorbitol in the growth media in order to slow down the growth to reduce the requirement for subculturing the media. So addition of sorbitol in the media managed to slow down the growth of the tissue culture. So we don't need to subculture it frequently. So we can save costs on that and labor costs on that. So another in vitro conservation technique is the germplasm under suspended growth, which is cryopreservation. So what is cryopreservation? Cryopreservation is, it involves the storage of cells, whole tissues, such as zygotic embryos, embryonic axis, somatic embryos, adventitious shoot tips, cell suspension, callus or meristem, or any other growing part in plants, which can form into plants. They stored in a very ultra low temperature, which is negative 196 degrees Celsius, normally in liquid nitrogen. So at this temperature, in theory, cell division and metabolic process will stop, and sample can therefore be stored at for unlimited period of time. So there are numbers of cryopreservation techniques that has been developed worldwide, such as air drying, classical freezing, encapsulation dehydration, complete vitrification, encapsulation vitrification, and droplet vitrification. All of these technique is species specific, and the aim of this technique is in order to eliminate the moisture content in the sample in order it to survive in liquid nitrogen without any freezing injury occur in the cell that we have conserved. So this is the example of liquid nitrogen tank that being used in cryopreservation. So this is for Mardi. cryopreservation laboratory in Mardi has been established on 2013, funded by the Malaysia 10th Development Fund, and research continued through the 11th Development Fund. All of the work on cryopreservation of plant in Mardi is performed in a framework of research only. So table below is a species explain and the technique and also the survival percentage of the sample after cryopreservation. So this is one of the technique that we have tried for cryopreserving citrus aurantifolia zygotic embryonic acids through the simple desiccation technique. Normally, we will take out the embryo from the seeds in order to get a very tiny sample in order to survive in cryopreservation. So we pre-culture in the media, we dehydrate it, we dried it in a laminar airflow cabinet, and we keep it in a liquid nitrogen for cryopreservation. And then after 1 to 2 hours, we warm it in a water bath and we plate it in a recovery media for growing. So this is the growth of cryopreserved citrus aurantifolia zygotic embryos exists after 1 month of culture using the simple desiccation technique. So this is a cryopreservation protocol for zygotic embryos of Lepiscentis fruticosa through the vitrification technique. We excise the embryo from the seeds and then we pre-culture it in a pre-culture media, insert it in a cryotube, and we soak it with a loading NPVS2 solution with a different duration treatments, and we plunge it in a liquid nitrogen for cryopreservation. After that, we pour it in a water bath, and we wash the sample and we blow dry in a media, and we culture the sample in a recovery media. So this is the growth of cryopreserved Lepiscentis fruticosa embryos after the cryopreservation through vitrification techniques. So with that, I think I have covered all of the topic outlined. So thank you, and thank you for your attention. And I hope that all of us will be protected during this COVID-19 pandemic situation, and let us nurture the nature so that we can have a better future. Okay, thank you. I give it to you.
Thank you, Ms. Suryanti Rustam. It was really very nice, very informative talk on a very difficult topic on recalcitrant conservation, species conservation. Thank you, Madam. Our next speaker will be from Intellectual Property Organization of Pakistan, Mr. Muhammad Ismail. He will be talking on intellectual property rights and plant genetic resources. Yes, Dr. please.
Bismillahirrahmanirrahim. Assalamu alaikum and good afternoon, everybody. I am Muhammad Ismail from Intellectual Property Organization of Pakistan. As you know, my presentation is intellectual property rights and relation with plant genetic resources. These are outlines of my presentation. What we will discuss during my presentation is intellectual property and its rights, and then positive and defensive protection of plant genetic resources. Then there is question why plant genetic resources should be protected under intellectual property rights. And then what measures have been taken at international level by international community for protection of plant genetic resources under intellectual property rights. What Pakistan has done so far, and what are our recommendations for OIC countries. So first is intellectual property rights. What is intellectual property? As you can see from the left side of my slide in this presentation, intellectual property is basically brain to business knowledge management. One body has thought some ideas, he or she has expressed his or her ideas, and then she or he has taken economic benefit from their ideas. This is called intellectual property. Therefore, I have defined it, brain to business knowledge management. So different types of intellectual property rights, just for rundown for the participants who know about IP rights or who don't know about IP rights. First, patents. These are basically rights granted for technological developments, inventions, and innovations. Then there is another important type of intellectual property that is called industrial design. Patent is basically technological development, and industrial design is a design of that technological development. For example, some company has developed a new engine type of their car makes or truck makes or anything. But when they have developed new designs, this is called their industrial design right. Then another important type of intellectual property right is copyright. These are literary works, artistic works, cinematic graphic works, and all types of creativity or creative works. These are protected under copyrights. Another very important type of intellectual property related with commerce and business is trademarks. Trademarks are granted to business entities for their marketing and commerce work. Then an important type is also trade secret. For example, Coca-Cola, they have trade secret of their formula. There are so many other companies in the world who protect their ideas under the trade secret rights. Geographical indications, very important type of intellectual property rights and closely related with the genetic resources. Geographical indications are from some specific area. There is some human intellect for specification of these rights. For example, cheddar cheese is a type of intellectual geographical indication under intellectual property rights. Then integrated circuits, these are electronic, these are topographies for electronic products. And these are also very important type of intellectual property. Nowadays, we can see artificial intelligence and then computing and then space technology all are based on the integrated circuits of different types. Another type, plant breeders' rights. You are surely well aware with this type of right because we are from the agriculture community. So plant breeders' rights are granted for development of new plant varieties to the plant breeders. Then last but not the least is genetic resources, traditional knowledge, and folklore. Collectively, we call them GRPKF. These are types of intellectual property rights which are not granted exclusively to some person or some company or somebody, but these are collective rights of some community, some country, some region, or some localities. So these are some types of intellectual property rights elaborated here. And we are talking about the GRPKF. And not all GRPKF, but one component of GRPKF, that is genetic resources. So next, very important terms related to the protection of plant genetic resources are positive and defensive protection. Protection of. As far as positive protection of genetic resources is concerned, we call it these are rights that empower communities or states to promote their traditional knowledge, control its uses, and benefits from its commercial exploitation. Some uses of traditional knowledge can be protected through the existing intellectual property systems, and a number of countries have also developed specific legislations regarding positive protection. I have given only one example here. China grants patents for Chinese traditional medicines. There is another type of protection of genetic resources that is called defensive protection. We define defensive protection as it aims to stop people outside the community from acquiring intellectual property rights over traditional knowledge. For example, India, Thailand, Brazil, Argentina, so many countries have developed their searchable databases of traditional medicine that can be used as evidence of prior art by patent examiners when assessing patent applications. So these are two types of protections, intellectual property rights protections available for genetic resources and plant genetic resources. So why PGR should be protected? What is the reason? Number one is the benefit sharing with the local community, with the custodians, with the owners of these genetic resources who own traditional knowledge related to these genetic resources. Another type of protection, the importance is prior informed consent of the owner or local community. We can't use anybody's property or anybody's rights without his or her consent. So whenever a company or an association or another country is using one country's genetic resources, they must inform them for their research work. The genetic resources are being used. Then collective rights of community are there. The community which owns or who are custodian of these rights, they have collective rights over these genetic resources and associated traditional knowledge. There is another very important term, state ownership, which is being discussed at WIPO and WTO forums. Pakistan supports this statement that states are basically owners of these genetic resources as they are owners of the natural resources from their territories or their areas. Then another importance for protection of these plant genetic resources are commercial use by a particular community or locality. With their consent or with their approval, these can be commercialized. For research work, these genetic resources can be used voluntarily, but whenever there is commercial activity by the developers of technologies, they must share benefits with the communities from where these genetic resources have been taken. Then discouraging unfair competition. Yes, this is also a very important thing. When there will be sharing with the right owners and when there will be mentioning of this proper source, it will discourage unfair competition and the commercial entities will respect the rights of the owners of the genetic resources. Equitable use of resources is also mentioned under the CBD. This is also one of the purposes for protection of these plant genetic resources. So these are some types of importances. What is the use of these plant genetic resources under the regime of intellectual property rights? Now we will discuss what measures have been taken at international level by the international community. There was Convention on Biological Diversity in 1990s, and benefit sharing and prior informed consent are mentioned under this CBD. There is offshoot of CBD that is called the Nagoya Protocol. It was ratified by many countries in the world in 2010. Another forum we all know, very well-known forum, is the WTO forum. World Trade Organization during its discussions under Doha Round in 2001 also discussed protection of these genetic resources under intellectual property rights. And these discussions are still going on at the forum of WTO. Then World Intellectual Property Organization in the same year, 2001, developed its Intergovernmental Committee, IGC, on GRPKF, and they are working for development of an international instrument for which should be consented by all the members of the WIPO, but they are still working to develop an national instrument for the protection of plant genetic resources. So these are three different international forums which are working in the world for the protection of plant genetic resources and other types of genetic resources as well. So what Pakistan has done so far, some highlights of Pakistan. We are member of CBD since 1994. We have joined the Nagoya Protocol in 2014. We are a member of World Intellectual Property Organization in 1977, and we joined World Trade Organization in 1995. So Pakistan is part of all types of negotiations going on at the international level, at the forums of CBD, WIPO, and WTO. As far as our national legislation is concerned, our Plant Breeders' Rights Act 2016 and Section 15G of this Act mentions that every application for protection shall be accompanied by written consent of the authority or local community in case where the plant variety is developed from traditional varieties. So these traditional varieties are basically our plant genetic resource, which is being used by our rural community from decades. And also, Section 32 of this Act mentions benefit sharing under the CBD. As far as our patent law is concerned, Section 8 mentions novelty, and then subsection 2 and C elaborates that patent is not granted for traditionally developed or existing knowledge for use of genetic resources available or in the possession of a local or indigenous community. So if you see, this is defensive protection basically. Our PGR law provides positive protection, and our patent law provides defensive protection for the plant genetic resources. And under this provision, Pakistan and India revoked patents on neem and some other types of plants in US PTO and also in European Union under these provisions of this patent law. This provision is also available in the Indian patent law. So access and benefit sharing law, this is under process, and our climate change ministry is working on it. It will be exclusive law or act which will be dealing with Nagoya Protocol provisions, which Pakistan has ratified in 2014. So this is overall legal process available in Pakistan for the protection of plant genetic resources. And it is last slide of my presentation. What we will recommend our counterparts in our OIC countries. Number one is that there should be disclosure requirements in patent and PGR legislations, as we have this type of provision in our law in Pakistan. They should ensure compliance with access and benefit sharing framework. Who should ensure? The legal system of your country must ensure that there is compliance with access and benefit sharing framework. Whenever you are legislating, if you are working for amendments in your law, these things must be ensured. Then prevention from erroneous grant of patents. What is meant by erroneous grant of patents? Those patents which don't mention resource from where the genetic resource is taken. This erroneous grant of patent is exercised in US, in EU, in Japan, Australia, so many countries. But this is discouraged in Pakistan, China, India, Brazil, and so many countries. So our patent legislation must discourage erroneous grant of patent, as Pakistan's legislation does this. Then, establishment of a mechanism which guarantees proper access to benefit sharing. As we are working on ABS law, our other OIC member countries would also be working on it. So the countries who are members of Nagoya Protocol, they must enact their ABS law as early as possible. Then there is great importance to the role of the state over ownership rights, as state is the ultimate custodian and owner of the genetic resources, and the same regime is exercised in Pakistan. So this is all about my presentation. Thank you very much. If there is any question, floor is open now, please.
Thank you for talking on the intellectual property rights of plant genetic resources. It's really very important topic because when we use the plant genetic resources, then the access benefit sharing system is active. That's very important to have the intellectual property rights. Thank you for all the speakers talking on very important topics, and particularly the participants for their patience in listening. If you have any, now we enter in the very important part of this session, that is discussion and conclusions. I will request Dr. Ismail Abdul Hamid to please start with some of the discussion, and later on we will do something more conclusions. Please.
Assalamu alaikum.
Islam, please.
Yeah. So thank you, Dr. Abdul Ghaffar, for giving me the floor. And actually, Dr. Abdul Ghaffar, myself, Dr. Sadruddin Siddiqui will be participating in our discussion and conclusion for the first session today. Actually, myself and my colleagues in IOFS around me We are getting a lot of notes, and we learn today important information that we have to always keep it in mind when we are working with genetic resources, and of course for how can we start the collection of the samples, and also for those who issues related to intellectual property rights. If you allow me, Dr. Abdul Ghaffar, Dr. Sadruddin, we can open the floor for discussion, and we have already Dr. Samia. Yeah, please, Dr. Samia, if you allow me, Dr. Abdul Ghaffar, we can open the floor.
Yeah, please.
Okay, so Dr. Samia, please, the floor is yours. Just unmute yourself and speak.
Hello.
Yes, yes.
Assalamualaikum. Sir, I have the one questions to the intellectual property right to guide me how to commercialize these IPs. Okay, most of researchers have IP, but not give the certain direction how to commercialize, how to get profit for these innovations. To kindly guide us to how can commercialize these IPs, and how can get profit for the these innovations.
Dr. Samiha, thank you for the questions. Could you introduce yourself, please? Hello? Okay, so now if you allow me, we give the floor to Mr. Mohammed Ismail for if he has comment about the question.
Okay, thank you very much, sir. As far as I have understood the question from Madam, intellectual property rights, commercialization of plant genetic resources under the intellectual property rights. As I have given two examples of legislation, one from plant breeders' rights law of Pakistan, another from the patent law of Pakistan. So first I will tell you about the patent law. For example, you are a developer of some technology based on plant genetic resources, and you have taken those plant genetic resources from some specific area of Pakistan. When you have developed the technology and you have come to our office for the patent registration, we will demand a certificate from yourself, from the researcher who has developed the new technology, that you have taken the resources from the specific region. What is your agreement with the local community for the use of these genetic resources? So on the basis of that agreement between the researcher and the local community, the commercial income or the economic benefits which the researcher is gaining or the patent right holder is gaining, they will share benefit with the local community. What is the common practice internationally? There is 5 to 7% annual income sharing with the owners of the genetic resources for patent exploitation. As far as plant varieties are concerned, the same system is available under our PGR law. If you have developed some new plant variety based on traditional plant varieties from some specific area, you will have an agreement with the local government or whatever the arrangement is there in that country, and then you will share benefits and you will be getting commercial benefits or economic benefits from your new plant variety. So this is the agreement between the owners of genetic resources and the developer of the new technology for benefit sharing. So thank you very much.
Thank you. Thank you very much indeed, Mr. Ismail, for clarification. And if there is any other question, from the floor, okay. So Dr. Abdul Ghaffar, can now I give you the floor for conclusion, or I conclude from my end? It's
Thank you, Dr. Ismail.
Yeah, please, yes.
Thank you. You know, we started from this presentation on genetic resources, conservation, gene bank system, and challenges in gene banks. All the topics were covered in this aspect. Dr. Sadruddin very nicely presented all the topics on this particular subject. Then just plant exploration, population assessment, and collection is the main theme of the genetic resources. Unless and until we don't have the genetic resources, we will be unable to develop any crop varieties or any crop improvement program. Dr. Shakil Ahmed, we appreciate his efforts on presentation on this topic. Then identification of plant species is very important. As Dr. Ahmed Sultan, he gave the example of a plant collected from the herbalist. That was not the actual plant which they were claiming. You know, identification is very important. Without identification, there is a lot of adulteration and all malpractices, particularly these type of countries from where we belong. Ms. Suryanti Bastam, she talked on very difficult topic, and we appreciate her efforts. And I suggest the participants, the member state countries of the OIC, to get benefit from their experience and knowledge, because it is really, particularly cryopreservation is a more demanding, knowledge demanding job. Mohammed Ismail, he talked on the intellectual property rights. Of course, in this era of genetic resources, when the people, they are talking on the excess benefit sharing mechanism, unless and until we don't have the property rights patent from some part of the world or in the country itself, then we cannot talk on that. The examples are available in rice and all the some herbal plants. To my knowledge, almost all the topics were covered very nicely in brief, in limited time. You know, the topic is very huge, but the time, in limited time, we really appreciate the efforts by the presenters. And thanks for their presentation and sharing experience and knowledge for all the participants. They must be benefited from their knowledge and talks. Now, we believe that without linkage and partnership, no country can progress. We hope the comprehensive linkage among the different researchers of the OIC member states. We hope the best for having future some linkages and partnership and collaborative projects and work on plant genetic resources. This was all from me. If Dr. Sadruddin wants to say something, Dr. Sir, please.
Dr. Abdul Ghafoor sir, thank you very much for this conclusion about the different topic studied. I would just like to remind the participants that some of the countries have not submitted their questions, and on the basis of their answer depend upon our future strategy for continuing this process of training sessions and webinars. So we would request them to, as soon as possible, they could submit their questions to the Comstech headquarters by email to Mr. Jamil, so that we can review their answers. And yes, we would like that some collaboration and coordination is developed between the member states, and the participants are also agreeing to this. And if there are no more questions, then we can wind up this session. Dr. Ismail.
Okay, thank you. Thank you very much, Dr. Sadruddin, Dr. Abdul Ghafoor. It was a very important session in this morning, and I think now we can move to the second session, because I remember it will be a video about documentary video about comstech activities, or I recall that His Excellency Dr. Khurshid yesterday mentioned that maybe not, or it is
there.
It is there. Okay, good.
Yes.
So now we can, for the next 10 minutes, we will be entertaining the documentary video about comstech activities before we will going back to our next technical session regarding plant genetic resources utilization and information management. And this session, just to remind that it will be moderated by Dr. Rosalisa Julie Marty and from Marty, and we conclude the first session, and we are now moving to the documentary video about comstech.
comstech, the Ministerial Standing Committee on Scientific and Technological Cooperation of the OIC, Organization of Islamic Cooperation, was established by the Third Islamic Summit of OIC held at Makkah, Saudi Arabia in January 1981. The President of Pakistan is Chairman of comstech. The structure of the comstech consists upon the General Assembly, Executive Committee, General Secretariat, and Comstech Secretariat. The President of Pakistan chairs comstech as ex officio chairman and the Prime Minister as the co-chairman. Comstech General Assembly is composed of all the member states of the OIC represented by the Ministers of Science and Technology or other nominated representatives, the Secretary General of OIC, and the Coordinator General of comstech. The chairman nominates member states for the Executive Committee for a 4-year term. The Coordinator General is the Chief Executive Officer of Comstech Secretariat, who is assisted by the advisors and other required staff. Comstech is situated in Islamabad, the capital of Pakistan. The mandate of comstech is to strengthen cooperation among OIC member states in science and technology, and enhance their capabilities through training in emerging areas, undertake follow-up actions and implementations of resolutions of the OIC Summit, and to draw up programs and submit proposals designed to increase the capability of the Muslim countries in science and technology. The ultimate aim is to build and nourish a scientific culture in addition to using science and technology as a major contributor to socio-economic development and rapid industrialization. The objectives of comstech include assessment of human and material resources of member states and identification of scientific and technological needs and requirements of the Ummah. Building indigenous capabilities of member states in the fields of science and technology through cooperation and mutual assistance. Enhancement of cooperation and coordination in scientific and technological fields amongst the OIC member states with a view to achieving collective competence in science and technology for solutions of the problems of the OIC member states. And creation of an effective institutional structure for planning, research, development, and monitoring of scientific and technological activities at national, regional, and international levels. Comstech works in close collaboration with OIC institutions, member states, and their scientific and technological institutions, and also works with international organizations. Comstech has established Islamic World Academy of Sciences in Amman, Jordan, Comstech Inter-Islamic Network on Space Sciences and Technology in Karachi, Pakistan, Comstech Inter-Islamic Network on Water Resources Development and Management in Amman, Jordan, Comstech Inter-Islamic Network on Oceanography in Izmir, Turkey, Comstech Inter-Islamic Network on Tropical Medicine in Kuala Lumpur, Malaysia, Comstech Inter-Islamic Network on Information Technology in Islamabad, Pakistan, Comstech Inter-Islamic Network on Biosaline Agriculture in Dubai, UAE, Comstech Inter-Islamic Network on Virtual Universities in Tehran, Iran, Comstech Inter-Islamic Network on Science and Technology Parks in Rasht, Iran, Comstech Inter-Islamic Network on Nanotechnology in Tehran, Iran, Comstech Inter-Islamic Network on Environment in Khartoum, Sudan, Comstech Inter-Islamic Network on Veterinary Science Research in Khartoum, Sudan, Comstech Inter-Islamic Network on Renewable Energy Resources in Niamey, Niger, Comstech Inter-Islamic Network on Genetic Engineering and Biotechnology in Cairo, Egypt.
Comstack has been headed by distinguished scientists of Pakistan with international repute since its inception. Dr. M.A. Qazi was the first Coordinator General of Comstack and served from 1988 to 1996. Professor Dr. Atta Rahman led Comstack from 1996 to 2012. During Dr. Atta's tenure, among many other distinctive achievements, Comstack got a state-of-the-art building, headquarters of Comstack situated on Constitution Avenue, Islamabad. Professor Dr. Javed Laqari and Dr. Tariq Banori have served Comstack with additional charge of Coordinator General. Dr. Shaukat Hamid Khan, a physicist, remained Coordinator General of Comstack for 4 years, from 2014 to 2018. In April 2020, H.E. Dr. Arif Alvi, President of Pakistan, appointed Professor Dr. M. Iqbal Chaudhry, a renowned scientist of Pakistan in the field of medicinal chemistry, as Coordinator General Comstack.
Bismillahirrahmanirrahim. I'm very pleased to invite you to nominate for Comstech International Award for Science and Technology. These are very prestigious awards recognizing original contribution and innovation in the field of science, technology, and engineering. These prestigious awards are classified into two broad categories. Number one, lifetime achievement in basic sciences, physics, mathematics, alternating with biology and chemistry. Number two, excellence in science and technology. In year 2021, Lifetime Achievement Awards in Basic Sciences will be given to the scientists having significant contribution in the field of biology and chemistry, whereas Excellence in Science and Technology Awards will be given in the following four categories. Best Young Research Award for scientists under the age of 40 by 7th August 2021. Best Scientific Book Award to the author of an outstanding scientific book published by internationally renowned publisher during the last 2 years. Award for Patent to recognize individuals for outstanding contributions that have had lasting impact in furthering theory and development of commercial systems. The patent must have been registered during the past 5 years. Best Research Paper Award in Biology, Chemistry, Physics, and Mathematics to recognize outstanding research paper published in an international journal in the last 2 years.
I'm from Al Farabi Kazakh National University. My country is Kazakhstan. I've been selected for comstech Consortium of Excellence Fellowship and Training Program. I'm very happy and so excited because under this program I will visit International Center for Chemical and Biological Sciences, University of Karachi for 6 months. International Center for Chemical and Biological Sciences is one of the best research establishments in Pakistan.
नेक्स्ट सेशन एक 10 पे शुरू कर ये खत्म थैंक यू We will start our session on 1:30 Pakistan Standard Time as per our program. So there are just few minutes left. So we will be starting exactly after 2 minutes our session. And I would request all the speakers, resource person for the next session to be ready. The first is Dr. Yassin Nahdi from Tunisia.
Assalamu alaikum.
Wa alaikum assalam wa rahmatullahi wa barakatuh. How are you, brother?
Fine. It's nice always to hear from you.
Jazakallah. Shukran.
Alhamdulillah. Alhamdulillah. I can start, Dr. Sadar? Or?
Okay, I will just give overview that our technical session 3 is now starting, and the first presentation is by the brother Yassin Nahdi from Tunisia. He works in the National Gene Bank of Tunisia, and his topic is very important. It's information management in gene banks and available tools and resources. Now you can share your presentation and start.
Assalamu alaikum. Good morning, good afternoon, good evening. Let me, before starting my presentation, I would like to thank colleagues from BCI, participants, and the organizers of this webinar for this opportunity to share and discuss some knowledge and concepts about the genetic resources documentation. My presentation will be divided in 3 parts. The first part will be dedicated to genetic resources documentation in gene banks and PGR databases. The second part, I'll introduce the Green Global project. And the last part will be dedicated to introduce some global PGR databases, such Genesis, the Global Information System, EasySMTA, and others. During these 2 days, we have followed several value presentations, and you can clearly conclude the large amount of data generated by gene banks operations. In general, gene banks will have problems managing their collection and this type of data if they do not have up-to-date, accurate, and reliable information stored in a systematic and easily accessible way. So such a documentation system allows gene banks to use information to plan their day-to-day activities and to maximize the use of their limited in general resources. Also, without an effective documentation system, gene banks cannot develop with a clear sense of direction, and they cannot easily communicate or collaborate with other institutions. So the documentation system in a gene bank or an information management system is needed in general to set priorities, to plan activities. I saw in the presentation of Dr. Shakil, before going to collection mission, he did some activities. These activities can be easily done if a documentation system is implemented. So he can easily did some operations, what we call a gap analysis, and analyze what we have in a gene bank before going to collection mission. So the documentation system, and the reliable one, can help us to set the priorities, to plan activities, to manage resources, to monitor them, and also to distribute if one researcher and breeder can request this type of material. The documentation in a gene bank starts on the field while collection. And let me say that it can start before, because we can when analyzing or by analyzing this documentation system, start the collection mission from the gene bank, from the office. We can analyze what we have and what's the gap in the gene bank. And the documentation never ends. The story of an accession in a gene bank can be summarized as follows. So the three types of acquisition or the three sources of acquisition of an accession in a gene bank are the donation, collecting mission, and repatriation in some cases. So we have to check the duplicate, if there's any duplicate in the gene bank. If we have not sufficient or enough amount of quantity, this accession can be multiplied, can be tested, can be quarantined, etc., etc. So I'll give you the time to see this figure. So PGR database, as you see, is essential in the database. So it increases in general utilization of the genetic resources. This for breeders, researchers, and some other stakeholders. We can manage regeneration, stock, safety duplication. This work can be done by gene bank curators or gene bank manager. Also, it allows multidisciplinary activities such as core collection, formation, and evaluation projects. This also work can be done by crop managers. We can also identify gaps in the collections to efficiently target collection expedition, as I said, for explorers and collectors. And finally, also it helps policy decision or policy makers to make policy decision related to ownership and sharing of germplasm, as well as funding priorities. The factors affecting usefulness of a PGR database are really disturbing many centers, PGR centers, and also gene banks. And it can be also summarized as follows: the information quality, the accessibility, presentation of data. We have also in some gene banks low priority given for documentation. We also have some problems with qualified personnel. There's a high turnover, a lack of expertise in some cases, and also rapid changes in technologies in both domains, biodiversity and computer. So gathering data for database. So to facilitate data gathering and allow accurate observation, the data collector must have knowledge of the descriptors being scored. I will show you after, or I will demonstrate some website where you can find a lot of information on descriptors and also on standards, as Dr. Sadruddin said about the multi-crop descriptors. So Biodiversity International and FAO issues a compendium of descriptive information and traits that characterize a particular accession of a certain plant group, called a descriptor list. So this descriptors list provides a comprehensive list of characters and aims to standardize plant characterization by setting an international format. Included in a descriptors list are passport data, characterization, and evaluation. So the minimum data required in a database or in a documentation system, the passport information, we will see it after the slides. I will show you a website where you can find this. And also, I think an Excel sheet will be shared with all participants, where can you find some links to reach these websites. So characterization data also, there are some minimal descriptors of various crops as designed by biodiversity. Gene bank data, so we have material source, complete name and address, receiving date, total quantity, crop-wise quantity, accession number. digital object identifier, and this is a new concept developed by the Secretary of the Treaty and maintained also by the Secretariat. Moisture content, germination level, generation, date of monitoring, etc., etc. Any type of information can be stored or stored in a documentation system, in a genetic resources documentation system. So this is about documentation. So this part is dedicated to Green Global project. I'm actually Green Global expert. I work as a consultant with the Global Crop Diversity Trust to implement Green Global. So I will introduce this project for you. So this is the Global Plant Gene Bank Information Management System. It was green. So Green Global was green. The Germplasm Resources Information Network was developed by the USDA and recognized internationally as a superior gene bank management system. The need for Green Global, because of many national gene banks lack effective technology for documenting and managing collection information digitally. In 2008, Green Global was transformed to Green was transformed to Green Global by a grant from the Global Crop Diversity Trust and the common work with USDA Biodiversity International to enhance green to address global germplasm information management needs. Green Global is a software suite that enables gene banks to store and manage information associated with plant genetic resources. So any type of information, if we have seeds, cryo, herbarium, field gene bank, so we can stock any type of information related to plant genetic resources. As I said, so it can deliver that information globally. GG is a three-tier architecture. I will not explain more because it's technical, especially for IT, but this is a common network configuration. So we have user's PC, he has some tools, and the server side can be also managed by an IT administrator, where we have the Green Global database, the Green Global public website, and in the other side, we have the most important tool, which is the Curator tool, and another tool called Search tool. The updater, or the Green Global program updater, operates in all of the locally installed Green Global application. We can always find updates through this application and get it in our local installation. This is the most important tool for Curator or Gene Bank Manager. It's called the Curator tool. This application designed primarily for curators and gene bank workers who will create and manage their gene bank's data. Accession information, passport data, characterization, inventory, stocks, ordering, any information related to the plant genetic resources. We can manage it through the Curator tool. This is a powerful tool also to search any type of information stored in a documentation system or on database. So this tool can be launched from the Curator tool or also launched directly from the Windows Start Program list. And it permits the Curator or the gene bank to find in a short time any information related to any PGR stocked in the database. The public website, so this can permit you or any curator, any gene bank manager to publish his collection or its collection generally or globally. In this website, there's a shopping cart facility. So through this shopping cart, we can order or we can request any material, any available material. For additional information, there is a web page dedicated to Green Global project, and it will be shared with you an Excel sheet with some other links. And I think if I have some time, I will also go through this website. The third part of my presentation, as I said, will be dedicated to some global plant genetic resources database. The first one is Genesis. So in Genesis, or Genesis PGR, is the global accession level portal to plant genetic resources in gene banks. This website is maintained by Crop Trust, by the Global Crop Diversity Trust, in partnership with CGR Gene Banks, USDA, the European Community of Plant Genetic Resources, and other individual, regional, and national gene banks. The new thing, since 2018, a Genesis phenotypic catalog was developed and also merged to the Genesis PGR. So we can find any accession with its characterization data. Also, from Genesis and GLIS, which is the Global Information System, there's a mutual cooperation. There's some synchronization between Genesis and GLIS. When you have some information introduced to the Global Information System, it will be synchronized automatically to Genesis. And in both sides, if you have Genesis updated, GLIS will be updated, and the other side, it's true. The new thing in Green Global, the Global Crop Diversity Trust also developed now a new Green Global Community Edition, which is a 100% web documentation system. It's still a project, and you can also see the progress of this project in this link. This link also will be added to the Excel sheet. The next global database is the Global Information System, which is all maintained by the Secretariat of the Treaty. So as you see here, that there's more than 1 million DOIs recorded, active registrants from 45 countries and more, more than 2,000 genera and more than 9,000 species. There's also links to external systems and more than 20,000 relationships. The next one is EasySMTA. So by this tool, we can generate a report, an SMTA or an MTA, and report to the Secretary of the Treaty. And thank you for your attention. Dr. Sadar? Dr. Sadar?
Thank you very much for the very nice presentation.
Thank you. I don't know if I have.
Yes, you have very nicely explained all the process, and I think very helpful.
Thank you.
And we also appreciate your help in providing to the National Gene Bank of Pakistan for installation of this Green Global and other help on data transformation.
It was my pleasure.
Thank you.
Thank you.
I would request Dr. Rosliza from Malaysia, Mardi, to please join us.
Assalamualaikum.
Now you please take over as the moderator and proceed with the next presentations.
Thank you, Dr. Sadar, for inviting me to be the chair for this session. So I go straight to the second presenter for the lecture topics in this session, Dr. Mehraj Abasov. He's from Genetic Resource Institute of Azerbaijan National Academy of Science. His topic will be molecular techniques for study of genetic diversity in plant genetic resource. The floor is yours, Dr. Mehraj Abazov.
Thank you very much, Dr. Moderator, Dr. Sadraddin. I am also greetings all of you from Azerbaijan, and I would like to thank the organizers for this opportunity. And I do believe that this webinar will help us to know each other well, and we can do close collaboration in the near future. Today, I will try to give you some brief information about molecular techniques for study genetic diversity of plant genetic resources, as well as I will try to share some of my results. As you know, in all gene banks, people are using 3 types of genetic markers for genetic diversity assessment. It is the morphological markers, biochemical, and molecular markers. As you know, molecular markers, it is 100 years people are using the morphological markers for genetic diversity assessment, and it is very important. And these are related to shape, size, color, and etc. They have some advantages. As you know, it is the readable available, usually require only simple equipment. And disadvantage, of course, you know, it is subject to environmental influences. Traits is limited and limited genomic coverage. We are using the morphological traits in our gene bank. Not only one traits, we also use the combination of the morphological traits, and it gives us variation of the phenotype. If you look at the durum wheat, there are a lot of botanical varieties. For example, Lacerum has spike color, on color, and seed color white, and there is not hair in the seed. If compare with the second row, Athena with the Lacerum, only seed color is the red. People are using these traits in the breeding, and I want to say this protocol came from the Vavilov school. That's why former Soviet Union countries knows these traits well, and they're using in gene bank activity as well as in the breeding. For bred wheat also, you know, there is almost more than 30 botanical varieties. And these botanical variety traits also correlate with some diseases. For example, in our experiments, we have found that we have found that 82% of resistance and 64% of moderate resistant genotype had white spike. Therefore, Lacerum, which varieties belong to Lacerum, can be used in the breeding program for leaf rust resistance. Of course, people are using also protein markers. Protein markers, we're still using the protein markers in our gene bank. You know, it is available since 1950s. Also, there is some advantage, require simple equipment like morphological markers. Disadvantages also like morphological markers, it is subject to environmental influences and also limited in number. In our gene bank for wheat, we are using the gliadin and glutenin markers. Also for barley, we are using the hordein. For maize, we are using the zein markers for passportization, also genetic diversity assessment. One of our experiments I want to share, we have used the gliadin and glutenin markers, 24 durum wheat land races and breeding varieties. We evaluate the genetic diversity and passportizate it, and we have published in genetics journal. You can see in the genetics journal of the Serbia. Of course, now it is the famous genetic markers is the molecular markers. People are using in the international organization as well as the developed countries are using the molecular markers. Molecular markers reflect heritable differences in homologous DNA sequence among individuals, and DNA markers application is the wide. We can use it in the fingerprinting, diversity studies, marker assistant breeding program, F1 identification, and etc. In our gene bank, we have used the wrapped ISSR markers just 10, 15 years ago. Now, mainly we are using the SSR markers. We have for diploid wheat, tetraploid, the grape, and etc. We use the SSR markers, and we have published several papers on the genetic diversity. One of my results, it's egglot species. We have used 12 SSR markers, and it separates all the species, mainly U and D genomes, and it published in Genetic Resource and Crop Evolution Journal last year. Of course, molecular markers, we can use also gene-specific markers for screening genes. As you know, in the bread wheat, there are 3 sodium exclusion genes, 2 of them located in A genome, NAX1 and NAX2. In our experiment, we have screened these genes in the Triticum monococcum, Bioticum, and Urartu. And first time we identified that this sodium exclusion gene only in monococcum and Bioticum, and Triticum urartu, in Triticum urartu, salinity tolerance controlling by other types of sodium exclusion genes. Also, 1BL right translocation, you know, it is very important. We have screened also this translocation in our collections, bread wheat collections, and we have found this location in 9 bread wheat accessions, and all of them is highly resistant to stem rust and also leaf rust. Now we are using these materials in the breeding to create new varieties. Of course, you know, now it is the CIMI, CARDA, or other international organizations, maybe in Pakistan also. People are using also CAS marker. CAS marker is easy. If you have the real-time PCR, you can use easily. We also use the CAS markers in our gene bank. And in my experiment, we have screened 16 loci with the CAS markers. And we have found the LR34 and other genes in our accessions. Mainly, we have found FHP gene in 1 accession. You know, it is the fusarium resistance gene. It is very important. I remember I have done a part of this experiment in United States. We have tested 4,000 accessions. We didn't find, but in Azerbaijan accession, we have found this gene, and now we are using, and also my colleagues from the United States are using these accessions for breeding program. Now we can say ERA is the next generation sequencing. Now people are using the next generation sequencing for genotyping. We have also next generation sequencing, and mainly we are using the genotyping by sequencing. I think everybody knows this protocol. It is very famous. It is very famous protocol. It is highly sought and cost-effective methods which enable identification of markers and genotyping at the same time, does not require initial information on genome, and enable to fulfill direct genotyping of the plant and allow to define multiple SNPs. Here, you know, first we need to reduce genome complexity. You know, wheat genome is very complex. That's why we have used the PSD1 and EPK restriction enzymes. Firstly, restriction enzyme we have to use and reduce the complexity. Then we are using the barcodes. After barcoding, we are pulling all the samples in 1 tube, and then we are sequencing, and we got the data. Then data we can analyze some bioinformatics and biostatistic tools If we have the reference genome, then we can use the samples. If we have not the reference genome, then we are using mainly unique pipeline. In our experiments, I have done a GBS in the Durham with accessions. I have got more than 1,000 SMPs, and we evaluated genetic diversity. Then, for example, you can see here in the bread width, I have used more than 400 SMPs data, and it separates red seed accessions and white seed accessions, and we have published this data also. I have done also GBS in Eglops Taushi, and it also differentiate strangulata and also Taushi, strangulata and Taushi. Now, you know, DART-seq is also one of the main NGS-based genotyping protocol, and in Australia, in United States, they are using effectively. We have also used DART-seq. Just we have sent materials to CIMMYT and we got the data. In my experiments, we have applied DART-seq data for DART-seq for 150 Eglops species, and you can see it separates all species, and based on this data, we have created co-collection in our gene bank on Eglops Taushi. And last year, we have published also this data in Germany in Genetic Resource and Crop Evaluation Journal. Now, I can say one of the modern methods is also genotyping by multiplex amplicon sequencing. Mainly people have used this protocol for human genetics, but for plants also, Iowa State University designed the panel for barley as well as for maize. And in the first time, we have designed panel for wheat genome. We have designed 830 primers for wheat genome, and we have tested this panel on 400 bread wheat accessions. And then we compare our results, amplicon sequencing results, with the GBS results. You can see in the slide, A is the results of amplicon sequencing, B is the results of GBS. You can see here we have used also two varieties, Shark and Jafari. They are very close each other based on amplicon sequencing data, as well as based on GBS data. It shows our results overlapped with the amplicon sequencing data as well as the GBS data. As I mentioned, not only Iowa State, North Dakota State University designed also primers for barley, 365 primer sets. I have used also this primer set for cultivated and wild barley, and you can see red is the wild barley. It separated all species. Then, of course, we have done also structure analysis and structure analysis. If we can get the NGS data, because we can get a lot of SNPs, that we can use this data not only for genetic diversity analysis, as well as we can use this data for association mapping. And for barley, we have done also association mapping, and we have found two loci associated with spot blots as well, and also rust resistance. Of course, NGS-based genotyping and also molecular markers we can use, but we cannot cover whole genome. That's why people are using also whole genome sequencing. I know Rice Institute, they're using the whole genome sequencing, more than 10,000, 20,000 accession. And also, you know, people started pan-genome project. I know that wheat pan-genome project and barley is going over. In Azerbaijan, we also trying to use whole genome sequencing. We started with the pomegranate, and First, we sequenced the one variety, de novo sequencing, and we have done some analysis. We compare gene sets and genes with other organisms. And first time also we have identified SSR types and also SSR motifs. Also, we have done transcriptome analysis in 6 organs, and we identified that genes in the root expression level is higher than other organisms. We also started pan-genome project in the pomegranate. We have sequenced 7 pomegranate varieties of Azerbaijan. Now we got all data. Now we are processed on the bioinformatic analysis. Hopefully soon we will analyze all data, and we will publish one good paper. If you look at NCBI, you can find also our data. We submitted all data to NCBI. It is thank you very much for your attention. Hopefully we can do collaboration with Pakistan and other countries on the genotyping, and with great pleasure we will be happy to organize molecular markers NGS training course in Azerbaijan, and OEC countries can join also in our seminars and workshops in the future. Thank you, and I wish all participants success. Thanks.
Thank you, Dr. Behraj, for a very informative presentation. Okay, we go to the next speaker, Dr. Asif Javed, and I'm sorry, Dr. Yelan Turuspikov. He's from Molecular Genetic Laboratory of the Institute of Plant Biology and Biotechnology, Kazakhstan. He's delivering a lecture topics on deployment of SNP genotyping in wheat genetics and breeding projects of Kazakhstan. Dr. Yelan, the floor is yours.
Thank you very much. Can you hear me?
Yeah. Yes, very clear.
Well, assalamu alaikum, dear colleagues. Warm greetings from Almaty, Kazakhstan. First, I would like to thank all parties for the organizing of this very important seminar for Organization of Islamic Countries and the opportunity to talk about our ongoing research in wheat genetics. Actually, my lab is focusing on many different crops in Kazakhstan on studying genetics and genomics. But I was requested to talk about wheat genetics, and it's probably very rightful because wheat is very important crop in our country. And as this slide tells, I am from the Institute of Plant Biology and Biotechnology. It's organization under the Ministry of Education and Science of the Republic of Kazakhstan. Before I will start, I will probably should mention that our institute in the past was awarded by the Islamic Development Bank prizes for the Science and Technology Award in 2004, and the entire organization are thankful for this award, and it was very important for us as well for the country, as this event was widely covered in our mass media at that time. But today I would like to cover a story about the wheat growing, wheat production in Kazakhstan, challenges, and how development of wheat germplasm collection might help us in development of competitive wheat cultivars in our country, particularly by using genomic studies, the genome-wide association study approaches, and using CASP markers technologies. In previous speaker, my very good friend Mehraj Abbasov already mentioned about different types of DNA markers, and CASP obviously is evolving as very important type of markers for breeding activities. In this slide, USDA slide actually is telling about the location of our country. We are south of Russia and west of China. And we used to be part of Soviet Union. And this year we celebrate 30 years of anniversary for independence of our country. But traditionally, because we've been many years within the Soviet Union, we efficiently share germplasm with former Soviet Union republics like Ukraine and Russian Federation. And therefore we have a still have a strong connections with the breeding organization of those countries. As per Kazakhstan, on this map, you can see the major areas of wheat production in our country. Mostly more than 80% of the wheat we grow on the northern Kazakhstan in 3 regions, Kostanay, North Kazakhstan, and Akmola. Actually, on the western part, in the northern part and eastern part, we grow predominantly spring type of wheat. And on the south and southeast, we, in addition to spring type, we also grow winter type. So it's just telling that it's required, it's a large country by territory and required specific wheat project for each region. And therefore we do lots of both genetic and breeding projects for particular regions. As per the production of wheat, we are one of the top countries for wheat production and wheat exporters, as telling this slide. However, on the worldwide map in this slide is just showing where we now approximately in terms of worldwide map. We very much like as Australia, we have a large area under the wheat, but the production is very low because of many stresses we face. And major challenges are drought stress, heat stresses, and disease resistance, particularly rust diseases. Still, we have some prediction from FAO organization that potentially in the future, production of wheat may grow further up to the 3 tons from currently 1 ton per hectare. Therefore, we are very much optimistic and trying to use many different tools, of course, both modern breeding and genomics tools to improve the situation. And for this, we are happy to collaborate with many different countries, many different organizations. In my opinion, it's very important not only for the exchange of germplasm, but also for training, for the research, for the opportunity to train young scientists using modern technologies like genome-wide association studies and the genotyping using SNP arrays. This activity was very important for us because we've been collaborating with many European countries as well as CIMI. Dr. Reynolds participated in this adaptive project. This entire project was led by Dr. Griffiths from John Innes Center in the United Kingdom. Later, we continued our activity in 2018 and organized United Kingdom Central Asian Wheat Improvement Workshop in our city. And we've done this seminar based on collaboration from many UK universities and also CIMIT representatives, Professor Dr. Margunov. He used to work at CIMIT in Turkey office. And he invited many breeders from other Central Asia, like countries like Uzbekistan, Kyrgyzstan, Tajikistan. So it was a very good seminar for us, and we gained a lot from this event as well. And also annually we're holding some meetings of breeders in Kazakhstan. In few last years, because of pandemic, we're holding this, but we are occasionally meeting online and discussing our problems. And based on that, we built in our institute particular small wheat collection, but it's very diverse and genotyped nicely. I just will list it and we divided this collection on two portions. It's hexaploid and tetraploid accessions. First, we have 96 cultivars and promising lines of spring bred wheat from State Seed Trial Organization. This organization is very important in our country as it has many stations around the country and ability to test any new promising lines. And this collection was actually genotyped using 90K S&P luminare. And then we had 178 cultivars promising lines in land races. We collected from different breeding organizations within the country. This material also was genotyped using 20K S&Ps. Then we have materials from CIMIT in Europe that was previously genotyped by Axiom Arrays, Affymetrix. Then within the UK Central Asia event, we joined 250 cultivars and promising lines of winter wheat, Central Asian collection actually. So it's a collection combine accessions from Kazakhstan, Uzbekistan, Kyrgyzstan, Tajikistan, and also UK colleagues added some accessions from Afghanistan. This collection already genotype using 35,000 S&P markers. For the durum wheat, we have a good collaboration with our colleagues from Italy. It's 304 accessions of durum wheat. It's a major accessions covering from different major durum wheat producing countries, and also 81 accessions of wild tetraploid wheat species. In addition to our storages, we also keep these accessions collections at the Gene Bank of Kazakh Institute of Agriculture, which is also a major partner of our organization, and we are collaborating on many projects jointly. Of course, the first what we've done using this information, both collection and results of S&P screening, it's phylogenetic analysis, and we published this data in Plant Genetic Resources Journal a few years ago. And based on that results, we surprisingly identified that Kazakhstan materials based on principal coordinate analysis actually very near to US material, US wheat material. And I was just thinking how this happened and what could be reason for that results. And then I searched the literature. And because we've been part of Soviet Union, I searched the connections, history of exchange of germplasm between Russian Empire and USA, and found the information that, well, this is just another slide showing that Kazakhstan has a common note with accessions from US, and more distantly it's related to European material. And searching this literature, I found that the problem could be solved by studying the immigration of Russian Mennonites from Russian Empire to USA at the end of 19th century. And because they've been cultivating a red type of Turkey wheat in the territory of Ukraine and Crimea. And at the end of 19th century, they moved from Ukraine region to United States because of certain events that happened at that time in Russian Empire. Those are pictures above. It's German Mennonites at the end of 19th century, and below are communities of Mennonites in modern communities of Mennonites. And this is just a map showing that the location of those communities at the time of Russian Empire and the settlements of those communities in the United States. It's a modern time. And the thing is, the results of US reports for wheat studies suggesting that more than 60% of modern wheat cultivars of United States were descended from those sources from the Turkey red wheat type of wheat brought by Mennonites. And therefore we concluded that that this might be reason for the close connection of relationship, phylogenetic relationship of Kazakh materials and US materials. We still, because we still have lots of connections with Russian breeders and breeders in Ukraine. On this slide, I would like to show the locations of breeding organizations in Kazakhstan, with breeding organizations that collaborate with our institute via different projects, and just showing the diversity of different ecological niches. This slide on the left from the map, on the right side of the map, is just showing outside of our city, our experimental plot at the Kazakh Institute of Agriculture. On the bottom left side is the northern territory of Kazakhstan, and the bottom right side is the stressful environments near Aral Sea, which is, you probably know, evaporating city in southern Kazakhstan. So we have many different environments and many different problems for each environment, and mostly it's a very stressful conditions causing by predominantly by drought stress and rust diseases. According to some publications, in certain years we have losses up to the 45% due to drought stress, and up to the 30, 40, and 32% for the different rust diseases, particularly for the leaf, stem, and yellow rust. And of course, those figures are extreme. It's happening in certain particular years, but for example, drought is happening once every 3 years. And to work on these projects, we joined our efforts with breeders in different regions of the country. In particular, we've been working on testing of the collections of wheat at the Institute of Barayev, which is in the central part of the Kazakhstan, no, the northern actually, near the new capital, which is now called Nur-Sultan. And for the leaf, stem, and yellow rust, we've been cultivating another collection. And all those samples were, as I previously mentioned already, genotyped using S&P luminaries. And we genotype this material based on a collaboration with our European partners, particularly the Gattersleben in Trade Genetics company. And we've done this for free. This is just was a benefit for us because we not only genotyped but also trained our young scientists for these new technologies. And we also done analysis for the LD-decay for all 3 wheat genomes in averages. This is the approximate field location of the Barayev Institute for the drought stress project. We've done this using collection of spring wheat, and we've done it using randomized complete blocks, 2 repeats in 3 years at 2 sites irrigated and rain-fed, and at the irrigated sites it was watered at tillering and rooting stages. And this is the correlation output analysis from the analysis of the major agronomic traits we studied, like heading date, seed maturation date, plant height, peduncle length, spike lengths, number of productive spikes, number of kernels per spikes, 1,000 kernel weight and yield per meter square. And at the rain-fed or non-irrigated sites, we found that heading type should be earlier for the higher 1,000 kernel weight and yield. Also, we've been studying the performance of the collection in comparison to local standards, Celina jubilejная. Celina jubilejная right here on the map, in this plot, and all those accessions were performing better than standard. In particular, these 9 accessions were showing outstanding performance for yield. And using Finlay-Wilkinson regression analysis, we identified 4 accessions that were stable in all 3 tested years for yield performance, and we recommended our breeders to use these accessions for the breeding schemes. As per the GWAS analysis we've done for the studying those listed agronomic GWAS analysis and here the general map of QTLs for identified QTLs for studied traits. Of course, it's a low resolution map, but general output is we identified 12 QTL for irrigated sites, 13 for the rain-fed, and 25 irrigated and rain-fed both. So the total number of identified QTLs for the 7 studied agronomic traits was 50. And also, we've done separately projects for the leaf, stem, and yellow rust resistances, and those are very common diseases in Kazakhstan, particularly in northern region. And here at the bottom are the causing agents for those diseases. We performed several experiments, and I would like to share results just shortly about our recent data we performed at the southern Kazakhstan and southeast of Kazakhstan. And for this, our collection was assessed using the COBA scale, and later we converted this COBA scale to 9-point scale right here for the GWAS purposes, for the just suitability for GWAS study. And this slide is just showing actual field output from 3 diseases: leaf rust, stem rust, and yellow rust. The southeast region in Kazakhstan, as you see that we had many accessions very susceptible both for the leaf and stem rust, and but for the yellow rust we've been more or less diverse reaction. And here also the just general output slide for the QTLs we identified, QTLs associated with resistant to these 3 diseases. And we generally identified 23 QTLs for resistance to leaf rust, 14 to stem rust, and 8 for yellow rust. The comparison of our results with available data on the published elsewhere allowed us to conclude that 3 QTLs for leaf rust and 1 QTL for stem rust are probably novel quantitative trait loci. Each accession, so we've been analyzed each accession for carrying the positive mean, I mean the resistant QTNs for all those 3 diseases like leaf, stem, and yellow rust, and we provided this information for breeders as a sources for possible resistance to all the 3 diseases. We also done some similar studies for tetraploid wheat accessions, particularly for durum wheat. Together with our colleagues from Italy, as I mentioned, we've done the same GWAS study for identification important QTLs. And we recently published this data in PLOS ONE for the durum experiment and for the hexaploid bred wheat experiment in PAJ. And what we do right now is just we are collecting all this information related to QTNs, so quantitative trait nucleotides, in order to convert them to CASP markers. Dr. Mikhraj Abbasov already nicely explained this methodology. It's very easy, it's very fast and high throughput methodology. And it's not required electrophoresis anymore. You just need to do PCR and screen it using the analyzers, Fred capability analyzers. And then eventually you get the information on the output using specific markers. And we are using this information to set up developments of number of CASP markers for different regions of our country, for different stresses available in different organizations, for example, for drought, stress resistance, for the diseases. And recently we started also work on the grain quality traits analysis. I will skip this probably conclusions because it's just repetition of what I already said in order to save time for other participants. And I just use this last slide to acknowledge help from our wheat community. Too many breeders to acknowledge, but I'm thankful all of them. for the support and for collaboration. Obviously, collaboration is very important, both for the exchange of expertise and exchange of germplasm and conduct important experiments in different regions of our country. For the drought stress, I'm particularly thankful to Dr. Babkenov from the Barayev Institute in Short-Andy City. It's close to our capital. Those are two of my PhD students work with Dr. Babkenov. For the rust diseases studies, I'm thankful to Dr. Aralbek Saliyev. He is a phytopathologist from the Research Institute of Biological Safety Problems in the Jambul region, Kazakhstan. And of course, I would like to thank my young, very enthusiastic and young laboratory, which working on many different crops, and particularly for Akirke and Yulia. They both worked on wheat projects. And finally, I would like to thank our grant provider, which is the Ministry of Education and Sciences of the Republic of Kazakhstan. And we recently also received a nationwide project from the Ministry of Agriculture, and we are looking forward for future joint efforts. And I'm using this opportunity, likewise, Dr. Abbasov, to invite for collaboration our partners in Islamic countries, and we would be happy to collaborate and use our possibilities for future to build strong partnership. Thank you very much.
Thank you, Dr. Yelan, for your presentation, which is, we can see how the technology that you explained is very important in the breeding program of wheat in Kazakhstan. So thank you again for your very informative presentation. Okay, next I would like to call upon Dr. Asif Javed. Dr. Asif is a resource survey.
Bismillahirrahmanirrahim. Thank you very much, Dr. Rose Liza. As we know that utilization of plant genetic resources is very important for crop improvement and food security. And Dr. Mehraj Abbasov and Dr. Yelan Turuspikov have explained well that how the genetic potential of plant genetic resources can be uncovered through characterization and evaluation using different markers. And Yasin Nahdi has explained that how the information about genetic resources can be made available and accessed for their utilization. The topic I want to discuss today is pre-breeding for utilization of plant genetic resources in crop improvement. We know that objectives of crop improvement are higher productivity, improved quality, disease and insect resistance, tolerance to biotics and abiotic stresses, and resilience to climate change. And the targets of plant breeders keep on changing according to the situation. Because with the new production practices, new pest or disease problems emerging, new market demands, and climate change, these are the factors because of which the objectives of plant breeders keep on changing. Since the advent of agriculture, humans are doing plant breeding. The combined forces of human and natural selection produced a wide range of genetic diversity that gave crops the ability to adapt to different climates, soil types, photoperiod, and to meet the requirements for different management systems, market determined quality traits, etc. And with the advancements in the science of genetics, modern plant breeding was born, and scientists began to understand how genetic information could be applied to improving crops. Scientifically based plant breeding allowed dramatic changes in the ways that new varieties are produced. We know the role of plant genetic resources in crop improvement. Plant genetic resources provide the building blocks that plant breeders use to design and construct the new varieties. We know that plant genetic resources include modern varieties, land races, and wild relatives. All of them have their role in crop improvement. This is a flow chart, how the germplasm goes from the gene bank up to the farmers. The first thing for utilization of genetic resources is characterization and evaluation. And Dr. Mehraj Abbasov has explained well about different ways of characterization and evaluation, like agromorphological markers, biochemical markers, and molecular markers. Then comes pre-breeding, then plant breeding and crop improvement, and new varieties go to the seed industry and then to the farmers. The conservation of genetic resources in the gene bank and their characterization and evaluation are the responsibilities of gene bank managers who deal with plant genetic resources, while plant breeding and crop improvement is done by plant breeders who develop varieties. And pre-breeding is in fact a bridge between gene bank managers and plant breeders. And it is not well defined that where the characterization and evaluation ends and pre-breeding starts, and where pre-breeding ends and plant breeding and crop improvement starts. Pre-breeding aims to isolate desired genetic traits from unadapted material and introduce them into breeding lines that are more readily crossable with modern alien varieties. This illustration by Tanksley explains the process of pre-breeding using crop wild relatives very well. Because when through selection the land races were developed from crop wild relatives, some characters were lost that helped the wild relatives to survive in wild. And when modern varieties were developed from the land races on the basis of specific characters, then some other characters were lost. Those characters were helpful in adaptability of plants and disease and stress resistance. So the objective of the pre-breeding is to recapture lost beneficial genetic diversity, to bring those characters back to the modern varieties so that we can have the characters of the climate resilience and climate change resilience and resistance to insects, pests, and abiotic stresses. Pre-breeding is not necessary if desired genes are available in one of the following. One is commercially available, adapted and acceptable cultivars, advanced selections, well adapted to the target environments, gene bank accessions that are well adapted to the target environment. If we have desirable traits in this germplasm, then we can proceed for crop improvement using the conventional plant breeding. Sorry, it is. Yes, the pre-breeding is necessary if desired genes are available in one of the following. Gene bank accessions that are not well adapted to the target environment, closely related wild species that are easily crossed with the wild species, more distant wild species which are more difficult to cross. So in that case, we will need pre-breeding. We know the knowledge and skills of gene bank managers. They conserve the widest possible diversity safely in ex situ collections under standardized protocols for the species in question. They follow standards of regeneration and viability testing to minimize risk of loss. They gather and organize the passport data provided by collectors, including any available information about the traits and performance of material where collected and the area itself. Manage the information to minimize errors and to maximize the utility of accessions. Characterize the germplasm for those traits that are environmentally stable and serve to reliably aid in identifying an accession. This can involve whole plant or molecular traits, which may or may not have any relationship to traits of economic importance. While plant breeders, they evaluate a broad sense of germplasm to identify sources of genes to combine into varieties that will be superior to existing ones in some significant way. The germplasm base of choice typically includes materials that are generally well adapted to the target region for the breeding program. The reason for this preference is that using a poorly adapted parent will bring a set of undesirable genes into the breeding population, along with the gene or genes of interest. Then the breeder will normally need to work for several additional generations to select out these undesirable genes while tracking and selecting for the desirable ones. After extensive testing, including input from farmers at all levels, breeders work with seed multiplication, certification, and distribution systems to assure that farmers receive the intended benefits. So this is how plant breeders develop the new varieties. For pre-breeding is in fact a teamwork in which gene bank managers and plant breeders both are important. Gene bank managers understand scope and value of germplasm collections, while plant breeders use their knowledge of genetics, physiology, plant nutrition, agronomy, molecular biology, and other disciplines to bring together important traits in plant varieties. So, plant breeding and pre-breeding, it is the collaboration between gene bank managers and plant breeders. And in case of pre-breeding, there is more likelihood of complex issues for crossing. And in pre-breeding, large proportion of undesirable genes in first generation crosses that are needed to be systematically and efficiently removed in subsequent generations. And in case of pre-breeding, end product is part of breeding population rather than a variety. That breeding population can be used by plant breeders to develop new varieties. There are two kinds of pre-breeding strategies. One is choose first. In case of this strategy, while materials that express a certain trait of interest are chosen on the basis of phenotypic, genotypic, or collection locality data and are used in targeted crossing, then the offspring are evaluated. This is called introgression. And the second strategy is cross first. It is a wider range of wild and domesticated materials that are crossed, and the resulting progeny are screened for traits of interest in the domesticated background. This can be called as base broadening or genetic enhancement. Modern crop varieties are the result of years of careful crossing and selection of highly refined, generally genetically uniform material. Some of these varieties have been so successful that they have been adopted over large areas. The irony of this success is that it can leave the crop vulnerable to pests and diseases or other environmental variations. If a pest evolves new biotypes for virulence on such a variety, suddenly there is a large area planted to susceptible material and an epidemic could follow. That's why broadening the genetic base to reduce vulnerability through pre-breeding is important. And it isn't only modern uniform varieties that can encounter intractable problems or become vulnerable to potential threats. If a new market develops with specific quality traits, the existing variability, even in a traditional farming system, may be inadequate to meet the demands. And climate change could present new situations for which neither the farmers' varieties nor the breeders' readily accessible breeding materials can adequately address the problems. Therefore, the new sources of genes, including crop-wide relatives, are important. And there are many sources of useful traits within the pool of both cultivated accessions and wild species related to crops. But crop improvement using wild species is a tricky business, as they often also contain, in addition to positive characteristics, traits that are undesirable. Wild species may have genes that reduce yield, even while providing genes for pest resistance. So the aim of pre-breeding is to incorporate the most useful characteristics while minimizing the addition of the deleterious traits. While recognizing the potential value of wild and landrace resources, plant breeders are often reluctant to use these resources in breeding programs involving their highly bred varieties produced from so many years of careful refinement. That's why it is important that through pre-breeding, we develop the lines that plant breeders can more easily use in their breeding programs. We all know about the crop gene pool concept given by Harlan, that there is primary gene pool, secondary gene pool, and tertiary gene pool. So if we do not find the source of our desirable genes in a primary gene pool, we go for the secondary and then tertiary gene pools. And for that, pre-breeding is important. Yeah, according to studies, for some crops, the domesticated gene pool or primary gene pool is sufficient so far for providing the desirable genetic diversity. For some crops such as alfalfa, cassava, chickpea, cowpea, finger millet, maize, and sweet potato, breeders have largely been able to find sufficient sources of resistance and variation for traits of interest within the domesticated gene pool. Wild species in each of these cases have been identified as potential sources for specific traits, but are not sought by breeders for the widening of the genetic base of the crop per se. But for some crops, due to insufficient genetic variation, crop-wild relatives and pre-breeding is important. Breeders in apple, barley, bean, bread and durum wheat, lentil, pearl millet, potato, rice, sorghum, and soybean in particular report a lack of genetic variation for traits of interest within the domesticated gene pool, necessitating greater exploration of crop-wild relatives. Many crops remain highly vulnerable to biotic stresses, such as bacterial or fungal pathogens without identified sources of resistance. Barley, apple, bean, lentil, and soybean experts emphasize large genetic bottleneck effects and insufficient genetic variation in cultivated varieties. Therefore, pre-breeding is more important in these crops. Regarding the pre-breeding efforts being done using crop-wild relatives, rice, tomato, and wheat in particular have sizable and well-established pre-breeding programs that focus specifically on crop-wild relatives, leveraging advanced genomic tools and diverse characterization and evaluation data. Relatively neglected crops such as cowpea, cassava, sorghum, sweet potato, and pearl and finger millets have yet to benefit from large-scale investment in pre-breeding programs and are therefore in the earlier stages of developing varieties using crop-wild relatives. And since in case of pre-breeding, we need to break certain biological barriers, so there are several challenges. These challenges include interspecific crossability, missing data on species basic biology like ploidy levels, life history traits, taxonomy, lack of understanding of gene-trait relationships, predicting how allelic combinations will be expressed in different cultivated crop backgrounds, transferring genes of interest from wild to cultivated backgrounds with precision, underrepresentation of wild species diversity in gene bank collections, unidentified and misidentified accessions in gene banks, and lack of characterization and evaluation data for gene bank accessions. Of course, scientific advancements are making new and new tools that can be used to address these challenges, like embryo rescue or transgenic technologies or marker-assisted selections. So using these advanced technologies, these biological barriers can be broken for crossing wild relatives with adapted cultivars for pre-breeding. According to a study, about the confirmed and potential pre-breeding uses of crop wild relatives of the 10 crops, the characters mostly for which the pre-breeding is done are biotic and abiotic stress. As we can see that in case of sunflower, the most of work is done on biotic stress, fertility traits, and abiotic stress. While in case of wheat, it is about the biotic and abiotic stress. In other crops also, most of the work on pre-breeding is done in case of biotic and abiotic stress. And in case of different characters like biotic stress, abiotic stress, agronomic traits, fertility traits, quality traits, physiological traits, and morphological traits, the more potential pre-breeding uses in case of biotic stress. In case of biotic stress, the work is most of the work is done, but the potential is also greater. In case of abiotic stress, also we have great potential in case of pre-breeding. So it means, according to this study, pre-breeding is mostly useful for biotic and abiotic stress. Crop Trust has initiated several pre-breeding initiatives in the world using crop wild relatives. These are on the 19 different crops, and several advanced lines developed using the pre-breeding are made available for plant breeders to use in crop improvement. So in case of pre-breeding, it is like a teamwork. So collaboration among different countries and different research institutes is very important for pre-breeding and development of advanced lines that can be used for crop improvement and food security. So this is all from me. Thank you very much. Dr. Roslisa, would you please invite?
I cannot start my video, but it's okay. I can just the next presenter. Thank you, Dr. Asif Javed, for the presentation just now. Our next speaker is Brother Khalid Abdul Rahman, the Operation Team Leader for Agriculture Infrastructure Development Bank, Saudi Arabia. He'll be talking about funding opportunities for establishment of national and regional gene bank food security projects. Brother Khalid, the floor is yours. Is there Brother Khalid in the line?
Hello.
Okay, all right, Brother Khalid, the floor is yours. You may continue.
Thank you very much. I was muted and I was unable to share my my screen.
Okay.
So
Secretary,
the host, can you ask the host to give me the function of sharing?
Okay, okay. Secretary, could you please able Brother Khalid for him to share the PowerPoint from his side?
Okay, I can share now, right?
All right, okay. Could you put it on the slideshow mode?
Can you see it now?
Yes. Okay.
Okay, thank you very much. And I've been trying to start on time, but apologies for that. I was unable to share and I was muted. Like I was not able to talk as well. So thank you very much for the organizer for allowing me now these two functions. So my name is Khalid Abdurrahman. I am the operation team leader for agriculture infrastructure in ISDP regional hub in Morocco. And previously, since I just joined this year in the regional hub for the agriculture portfolio in Morocco hub, covering 5 countries. However, I was working across 57 member countries of ISDB with the global practice arm of the bank, economic and social infrastructure department. And before that, I was also doing portfolio management in the agriculture sector, agriculture and rural development sector. So I've been in the bank for 7 years now, and I am engineer by training. So, and I've been working along different infrastructure and processes along the agriculture and rural development value chain. So today I'm going to present to you the role of ISDB in fighting for insecurity and eradicating poverty in ISDB member countries, more specifically focusing some examples from Africa. So in fact, ISDB has, as you all, some of you may know, Islamic Development Bank has 57 member countries, is spread over 4 continents. And this has come from a journey when it was 23 countries in 1975, and until they grown up to 57 member countries in 2016. ISDB, it has 11 regional hubs in Bangladesh, Egypt, Indonesia, Kazakhstan, Morocco, Senegal, Suriname, Turkey, Emirates, and Uganda, and as well as Nigeria. So we work across Asia and Latin America. I mean, regional-wise, where we work across Asia and Latin America, Middle East, North Africa and Sub-Saharan Africa, Europe, and Central Asia. So this is our coverage, as well as our in terms of regional offices, as well as in terms of portfolio. So in fact, ISDB is working in the agriculture sector through 2 levels, basically aiming to achieve impacts to which ISDB contributes. Level 1 is agricultural contribution to economic growth and inclusive development, and and level 2 is agricultural transformation, sustainable growth. So in fact, the 57 member countries are endowed with enormous resources to develop sustainable systems. And the main features are as follows: 29% of the world's 29% of the world's agricultural land is it's found within ISDB member countries. 14% also, it has 14% of the world's total renewable water resources, and it produces 18 out of 20 world's major agriculture commodities, and 15% of the world's cereals and horticulture products are coming from mainly 10 member countries of ISDB. And despite these resources, food insecurity is prevalent in ISDB member countries, and nearly 1/3 of the 700 million people globally hungry and malnourished live in our member countries. The causes are many, including conflict in many countries. A few important cross ones are low productivity and low productivity of the farmers, and most are smallholders, and as well as the poor links for markets, and value chains of most of commodities are weak or broken. And number 3 is that absence of financing, or absence of even affordable financing, is one of the main reasons that hindering this sector to grow. So the 4th thing is the climate change and the climate variability. So our increased incidence of droughts and floods in our member countries, and the policies as well, the weak and the poor and not sometimes non-functioning policy that can incentivize the private sector and production. So the importance and impact of integrating governance and agriculture. This is really very important because when you compare poor governance with good governance, you will find a list of issues that coming out of that. One of the major, the poor governance is one of the major driver of food insecurity, and current policies and programs that address agriculture and food security are hindered by complex political processes and interaction between stakeholders, government, private sector, and farmers. Also, unequal power and access to resources, poor institutional capacity, and weak design and implementation of government policies. While on the other hand, when we have a good governance, this will support the aim of agriculture and food security through multiple pathways, and it will respond to a food crisis and it will address issues related to the hunger, and it will help in establishing programs supporting agricultural strategies. It will include all the civil society, technical partners through strong partnership and connectivity. And it will help adopting the value chain approaches that are inclusive of women and youth, which often left out by during the decision-making process. So here is a diagram just trying to elaborate somehow on the ISDB agriculture policy and what it aimed at and what its main pillar, in fact. So the main goal of ISDB agriculture and rural development policy is to have a growing, inclusive rural economies. So this is a overarching goal for the policy, and this will be achieved through, or is being achieved now, even through food security and rural development sectors. So the policy has 6 priority areas. Basically, it talks about resilient and climate smart, resilient and climate smart agriculture. And the second pillar is human and institutional capacity. The third pillar is access to markets. And the fourth pillar is inclusive, sustainable, integrated approaches. And the fifth pillar is access to Islamic finance products and services. So, and the last one, the last but not the least, is the private sector participation. So the expected outcome of the policy implementation during a period of 5 years, which started in 2019 and supposed to be updated by the end of 2024. So it aims to create 2 million job opportunities, 2 million job opportunities. And also it aims at a 30% increase in smallholder farmers' incomes. And it aims at the climate change resiliency to be enhanced. So these are the main features of ISDB policy framework. And also just to highlight, ISDB preparedness, ISDB, they have a couple of featured programs. One of them is ISDB preparedness and response package, which we call it 3 Rs. It has 3 main action interventions around the principles or the concepts of response, restore, and restart. So the idea, this package is basically related to the COVID-19, the recent pandemic, which started in December 2019, and it aims to help the member countries to respond adequately and to respond efficiently, effectively to the impacts of the pandemic. So the first phase of, now we are currently in the first phase of this package, which is a response, and basically it includes health and food security interventions and activities to sustain and save life. And some of the activities also started the Restore program, which is basically a alliance of finances for micro and small and small and medium enterprises to help the private sector survive the pandemic's peak effects on the economy. And the third pillar of the program is which is basically a long-term one, is the restart. So this aims basically to build resilience and robust key industries, including agribusiness, and catalyzing private investment. And the total amount of this program, of this IGB preparedness and response package, is $2.3 billion. And also it has 1.5 billion COVID sustainable scope, and we aim to mobilize funds from the Arab Coordination Group in the amount of $10 billion. I cannot. Hello? Can you hear me?
Yes, yes.
Yes, we hear you.
Yeah. So here, this is another feature program. We call it the IGB Regionalized Value Chain Program, which is a powerful pathway toward alleviating poverty and food insecurity in sub-Saharan Africa. So the program has targeted 10 countries in sub-Saharan Africa, and it was designed and it has been designed based on a value chain approach. And it is vital initiative for beneficiary member countries in terms of achieving food security and food sovereignty, and also in terms of supporting the government trade balance and budget, because most of these targeted 10 sub-Saharan countries, they're having food deficit as well as they're having trade imbalance, because they're importing a lot of rice from abroad, and that making lots of challenges within these economies. So it is one of the strategic flagship program, and there are many partners working with us, including LLF. LLF, in fact, is a life and livelihood fund, which is run and administered by ISDB itself. And we have partners like Manope, UNDP, Africa Rice, AGRA, DC, and IFDC, and African Development Bank as well. So many partners we managed to mobilize through this regional program, and the total amount of the program financed by ISDB is 300 million, and several co-financers as well. The basic idea of this program is the basic concept. It targets of the problem of the land, the low land productivity in sub-Saharan Africa, which is less than 55% of average rice yields. And also the labor productivity is less than 60% in Asia and Latin America, than that in Asia and Latin America. So the percentage of agriculture exports fell from 15% to 4% as we speak. So this program is target this type of problem to boost up and improve the rice production and productivity. So let me just jump over this slide. So as I said, the program is basically using a value chain approach, addressing the different segments of the rice value chain, from the production through the processing until the market stages or milestones of this value chain. So it targets farmers and also processors and also people or farmers or associations and private sector who also work on the market side of the value chain. So the program is basically covering the production and productivity part of the value chain, as well as linking farmers to market through different type of infrastructure. And also in the production and productivity, the program targets things like irrigation infrastructure, like support to farmers in terms of training and awareness, agriculture, different agriculture inputs. We're working with many partners to enhance the agriculture, the rice seeds, and the different types of agriculture inputs, fertilizers and mechanizations, and so forth. And the main also we are focusing on the processing part of that with other partners. African Development Bank has joined us to work on this segment, the processing part of the value chain, the different infrastructure and capacity building program that's required for this part of the value chain to function very well. At the same time, the program works along the policy and institutional framework. The program provides funding for governments to conduct studies towards that's policy oriented, that aims to create policies and strategies in the agriculture and rural development in those 10 targeted sub-Saharan African countries. So it is very inclusive, comprehensive, and try to address the problem through a comprehensive approach, which is the value chain. So in conclusion, just would like to shed the light on IZB mandate and role, and what are the questions now on the table to handle the agricultural value chain, agricultural rural development, and the agricultural value chain and the food security challenges in our member countries. So basically, the priorities that we're talking about now is the governance and management models of agri-food systems and partnerships. So this is something we really put under focus, and we try to work with our partners very hard to improve on the governance and management of agri-food systems and partnerships. Because we realize if you don't work on the upstream side of things, you don't expect different results on the production and productivity side, which is a bit downstream side of that governance framework. Also, the legal and regulatory measures that can support the active engagement of the private sector in to ensure food security and poverty alleviation. Also, another important issue to look at, IZB has put under really focus is the issue of the value chain itself is to be comprehensive, is to be inclusive in addressing our different member countries' agriculture and rural development sector. So, and now we started 2 or 3 years back. Most of our programs and interventions in the member countries has been following this approach. We are not just now focusing on infrastructure, but infrastructure plus other soft activities, including capacity building, policy support, partnerships, all the package come together, trying to fill in the weak gaps or the missing gaps of the value chain. So the bend case, so we conduct thorough studies to understand the baseline, where are the missing links of the value chain before we start designing the project. So the third thing that we're also looking at the use of technology and introduction of technology in agriculture value chain. This is very important because nowadays we have so different and many emerging technologies that can help boost the production and productivity with minimum effort. So if we invested on those technology very well and introduce them appropriately to what we are doing, I guess this will be really value added to our investments. So the last or not the least, but the that we're focusing on is how to deploy how to de-risk the value chain investments. So because most of our farmers and smallholders in those member countries, they are passing severe challenges, crises. Those are some of them, they are natural crises like climate change impacts, some of them because of other human crises. And the challenge now is how to encourage and protect those farmers and to encourage them to sustain their business and sustain their activities in the agriculture sector and productivity sector. So now we are talking about this concept, de-risking the value chain, and how we can invest in that and to come along with the value chain packages. So I thank you very much for listening, and I'm sorry if I have taken more than the allocated time.
Okay, thank you, Brother Khalid Abdurrahman, for a very good presentation on explaining how the IDB play very important role in IOC member countries. So we heard from his presentation how IDB give assistance in carrying out project for food security and poverty alleviation in member countries. So as we can see, it's very aligned to the Sustainable Development Goal that now we are still finalizing on the post 2020 on how we want to make sure that poverty and hunger to be eliminated, especially in our member countries. So thank you again, Mr. Khalid, for your presentation. So this is the last presentation for this session. So our next is on discussion and conclusion. I would like to invite Dr. Ismail Abdul Hamid and Dr. Sadaruddin Siddiq to join me in this session. So we heard from our good speaker from the beginning, Mr. Yassin Nahdi, already talked on the importance of the information management in Gene Bank and showed various tools and resources that could be used by member countries. And we heard also from Dr. Mehraj and Dr. Yelan on the advanced techniques for plant genetic resource evaluation. Is for genetic diversity analysis and associated mapping using next generation sequencing, such as NGS and the whole genome study, which being carried out in Azerbaijan and also in Kazakhstan. So we see that it is a very important approach that we need to go to use to make sure that our breeding program is in the right track, because from there we can identify breeding line that are very good for to see in our diverse environment and also for the pest and disease resistance. So Dr. Asif also touched on the pre-breeding, the importance of pre-breeding for utilization of PGR in crop improvement. as for Mr. Khalid just now already explained very on the financial assistance, or maybe how we can see from the policy of the IDB that is supporting our member countries on to make sure that the inclusiveness and the comprehensiveness of the policy can help member countries in ensuring the food security for this region. So I would like to ask Dr. Ismail Abdul Hamid and Dr. Sadaruddin to make some comment on this slide. Dr. Ismail or Dr. Sadar, want to start first?
Okay, thank you very much for this moderation of this session, technical session 3 that we have just ended. And I think that all the presentations were very nice and very comprehensive and timely presented. And the message was very clear that we have to adopt the latest techniques, whether it is in the information management or the evaluation of germplasm or genetic resources, so that we can direct them toward the use and start pre-breeding with crop wild relatives, and also adopt the strategies to successfully implement the pre-breeding, because it requires many other techniques and it is not direct breeding. So we have to develop our capacity in terms of human resource as well as institutional capacity in terms of facilities. So I hope some support could be from the funding agencies in this regard, so that those institutes which are not having these facilities could develop and upgrade their facilities to perform for food security. And those of the OIC member countries which are advanced in certain technologies, they can serve as the center for research and training by mutual collaboration and regional setting up of the regional training centers, so that the other countries can come at par to and can benefit from the genetic resources that they are unable to characterize and evaluate due to lack of human resource. So as some countries have very advanced instrumentations and equipments like NGS systems, which of course it is very expensive, about 200 million, something like that. So not all countries can afford that, and it is also impractical to invest in that. Its operating cost is also very expensive. So those countries which have and not fully utilizing its own capacity, if they collaborate and offer services to the OIC member state so that they can send their material and get analyzed from those laboratories, I think it would also help in generating the data and making use of these genetic resources by other countries which do not have or cannot establish at hand in recent time such large scale facilities. So from the presentation by Brother Khalid Abdul Rahman about the funding opportunities, I would like to have some clarification on the first item, that is they want to build the human resource, human and institutional capacity. So I would like to have some feedback on that what would it cover for the human resource development of the national gene banks of the OIC member states, and the capacity building of the institute, which are performing the job for food security. They are providing the basic building blocks, which makes the crop varieties goes into the farmer's hand, and then farmer increases its income. If the farmer does not have as you have mentioned for Africa, that they are lagging behind in rice. They don't have the varieties which can perform well. They are down in all respect, and their export is also has gone down from 15 to 4%, I think, as you mentioned. So the outcome that Islamic Development Bank wants, number 2 and 3, that it's 30% increase at least in the farmer income, and the climate change resilience. So both of these are related to the development of improved varieties, which is supported by the genetic resources which are being conserved, evaluated, and then incorporated into the hybridization program that will give varieties of rice to Africa that will produce more and in the climatic situation that they are facing. So climate resilient varieties will be developed and farmer income will increase generally and its exports will also increase. So as I have mentioned last day in my presentation, that for example, if we want to export rice to Japan, we have to develop those traits that Japanese people would like to eat, that is the sticky rice. They will not eat the basmati rice or the indica type of rice that it is working on mainly. So if Africa wants to export, then they have to develop those characters in those rices that they, and so that they can export and also produce more. So I think I would like some comments from Brother Khalid Abdul Rahman about how it can be supported in this perspective, that for human and institutional capacity, how we can link together, please.
Thank you very much for your good questions. I don't know whether you want me to reply immediately to that or you have another round of questions. And
you can reply in the next section also, but you can note down, please, this very important question from us.
Okay. So this is a very good question and very important. In fact, the 10 or 15 minutes presentation will not definitely allow us to explain everything ISDB is doing and planning to do in the future, or is being doing at the time being. So the idea, as I mentioned in the policy framework, is that we work along. I mean, to the basic idea on the is trying to improve and enhance the investment environment in agriculture. One of the important things that we are doing now, and we've been doing along the past 40 years, and with more focus in the last 3-4 years, is trying to build the capacity of the institutes through multiple ways. In fact, this could range from providing support, providing, for example, technical assistance grants to those countries to build, to do studies, for example, policy-related study or small research that can help opening windows for a good governance and policy making process. The other thing, other instruments or mechanisms that we can use, normally we incorporate within our project design such soft elements, basically targets. Sometimes in the regional value chain program that we are doing in 10 sub-Saharan African countries, in fact, what we are doing is we are basically targeting rice research institutes. So we know these are key institutions to improve the agricultural production and productivity. So we know if we don't target the process of seeds production and the process of the seeds creation and manufacturing, will not be able to have a good varieties as you've nicely spoken about that. So we put those kind of research entities in our on the local level, and also we bring partners from our outside who have the capacity to help the local institutes in that direction. So this is one of the things that we do through our projects, either through direct funding to these research institutes through the program. We incorporate that funding within the program, or through bringing other partners with whom we have a good network and collaboration. We bring them, like what we have did also in the regionalized value chain program. We brought a lot of partners who are concerned and working on the research side of the agriculture. The other type of interventions we're doing is also through these funding programs, through this project funding. We also incorporate aspects for or components or subcomponents for direct for conducting studies related to conducting scientific or technical or feasibility studies sometimes to understand and to improve the investment environment for agriculture. So that's also in support to the policy. And we're also conducting and doing direct funding for direct capacity building programs for farmers and professionals who are working in the agriculture sector, whether in the local, whether in the government side or private sector or the non-governmental organizations. So we target the farmers and the professionals who help and support the farmers in doing their job as well, in doing their production in the field. So this is basically one of the very few activities, one of the activities, key activities or critical activities that we're doing through the programs. Internally, if we moved internally within ISDP, what we have done in the last 3, 4, 5 years, we have done a thorough reform to position ourselves to be a knowledge-based institution. And that's why now you have seen this policy, and you have seen our ISDP agriculture and rural development strategies, and lots of policy and knowledge products. If you go into our website, if you check in our website, you will find a lot of documents along this direction. So the reform happened in January 2018, and the continuous fine-tuning for that reform is basically aiming to position ISDB as a knowledge-based institution. At the same time, is to strengthen the linking part and the partnership with other institutions who can help ISDP in delivering impactful projects. On the agriculture, basically that applies to all sectors. When you trickle down to the agriculture and rural development sector, policy is there, the strategy is there, lots of knowledge products has been produced, lots of programs and partnerships we have been in partnership with FAO, IFAD, and many international organizations working so we are now co-locating and coordinating our efforts to maximize the impacts of our intervention, because what we have learned through almost 45 or more than 45 years of experience, that we cannot work alone in all the segments of the agricultural value chains. We need always to come with partners to maximize the impacts to the end beneficiaries. I hope I have answered your questions and clarified how we position ourselves.
I have one question, Mr. Khalid.
Sorry?
I have one question.
Yes, please.
You can
go ahead.
hear me?
Yes.
Kindly guide me some workshops and some video to how to write the proposals, because a lot of researchers and entrepreneurs have problem to write the proposal in your benefit. So kindly you develop the certain short videos to how to write the proposal for your domain and which sector you identify to get the grants.
Yeah, we have, for example, we have Science and Technology Innovation Fund that's open to direct beneficiaries and direct researchers and direct entrepreneurs as well. So, this, we call it, we have something called Engage platform. If you Google it online, this Engage platform will lead you to different initiatives by the Science and Technology and Innovation Department within the bank. So we have, the bank has established a fund just to boost and improve the science and technology and innovation part of the development. And that all aims to support the development interventions and impact at the end. So within that platform, there is a lot of information, a lot of guidances on how to develop proposals and how to get access to these kind of grants by researchers. So please do guide your networks and collaborators to this type of platforms. I will let our colleagues who are working in the STI fund and STI department, which stands for Science and Technology and Innovation, communicate with you after the meeting or after this event to guide you through the different websites and different programs and different material that we have online.
Okay, thank you, Mr. Khalid, for your feedback on how members can tap the funding in IDBs. Yeah. So, Dr. Sadad, are we going to continue or we should stop here now?
I think we can stop now, and we can have concluding remarks from Dr. Ismail Abdul Hamid.
Assalamu alaikum, the distinguished participants. Assalamu alaikum, dear colleagues. We apologize because Dr. Ismail involving in two big events of IOFS. He is, if you are just have an access and if you just want to, we are glad to see you in our another event, which is big event, which is jointly conducting with UN Food System. And we would be glad to see you maybe after finalization of this event. I would like to, on behalf of Dr. Ismail, and make some review of this session. It was very interesting session regarding the role of information system, especially in the gene bank creation and modeling. And you were so right, and I would like to I'm totally agree with Dr. Sadaruddin regarding the role of information of market in order, for example, to provide some export to Japan and other countries. And in this case, we can say that the role of smart technology and especially of identification of products starting from the gene become very important, because most of the disease in the worldwide, it's just food disease, food related diseases. And today we can say that especially creation of such events in the framework of sharing best practices is in advance. And the other practices shown that especially in CIS countries, including Tajikistan, Kyrgyzstan, Kazakhstan, Turkmenistan, Afghanistan, sharing best practices such in implementation of gene banks, especially in Pakistan, which is very valuable in Bangladesh, in Tunisia. And we can see that you are have very big achievements in this case. And I hope that after pandemic, we would be able to be in touch with you, maybe our specialists, especially from Central Asia, will be able to meet with you in person and sharing your best practices. Thank you.
Thank you very much. I would just like to give a brief review about the questionnaire that we have given to the, and we had some feedback. So most of the participants were gene bank manager, conservationists, and breeders. And they were all mostly primary users of the plant genetic resources and working for diversity conservation. And they all feel that there are many kind of threats to the plant genetic resources which are getting extinct. And the gene bank are established almost in all the OIC member states that are participating. So, and most of them are doing pre-breeding as well. They have given some constraint about financial issues and human resource issues. And in regeneration, some have reported the labeling problems and presence of duplicates within the germplasm. And most of the scientists are working with crop wild relatives and also utilizing them. The international treaties are being followed by most of them, and they are sharing their material with signing standard material transfer agreements. And also developing varieties. And there is considerable genetic resources conserved in the all OIC member states, particularly Turkey, which has the highest number of accession conserved, more than 100,000. And it is good to know that the germplasm that has been conserved is mainly dominated by indigenous collection. And all the countries are acquiring germplasm from abroad as well, and doing quarantine, phytosanitary certifications, and use of import permit for this. And all agreed to conduct such workshop in future as well. And most of the participants have asked that the next, if possible, it should be in Turkey. And some of them have also desired that the next such training should be in Indonesia, Malaysia, Kazakhstan, Central Asia, Middle East, and Southeast Asia. So, but most of the participants, they have asked that the next such session should be from Turkey. And except for one, everybody has agreed that the medium of language should be English. And the time has been said to be most appropriate and the number of days, but some people have said that more number of days would have been possible. Instead of 2 days, it should be 3 or 4 days to cover such a broad topic. So, and they expect that a lot of collaboration and coordination will occur due to this webinar workshop. So this is all about the feedback from the participants, from the questionnaires.
We can just let me make a few comments because we are at the closing stage. First of all, once again, I thank all of the resource persons who've made very valuable contributions to this training, and I hope that the participants have had further increase in their knowledge and understanding of the issues. Further, of course, we would like to again acknowledge our partners, IOFS and BCI, who have worked very hard to make this event possible and successful. Let me also take the opportunity to familiarize the participants of something that we have been trying over the past 3 years or so, and with regard to the PGR facilities and situation in the OIC countries. Dr. Sadruddin has been a leading person in that regard. Dr. Mehraj also has been very active with us, and also our colleague from Oman has been a part of our efforts. the status of our efforts basically is that we were able to write down a proposal for the enhancement of the PGR facilities in 5 of the member countries who are participating in this activity. This includes, besides Pakistan, Kazakhstan, and Oman, Azerbaijan, and Jordan. So we had proceeded quite far in having feedback from our members in these countries on what resources they have and what problems they are facing and what they in terms of manpower, technical support. But before the project could take the stage of going towards securing funding from different possible sources, we entered into the region at the time of the COVID-19 pandemic. And so that has been stalled to a large extent. But we have not given that up, and we intend to pursue it. We have the honorable representative from the Islamic Development Bank. And after this is over, we will share with them also the proposal that has been agreed on, see if they can give us some suggestions on how we can proceed on that direction. And that is basically having a multi-country proposal on plant-generated resources and their conservation and their exchange and integration in the seed system. So we will do that. And I think if Dr. Sadruddin and Dr. Miraj, others wants to follow up with the other countries who have participated in this workshop, and we can collect the similar kind of database from the other OIC countries, it would be probably very useful to have maintained such a database about the plant-generated resources and their status and their needs in the different countries. So that is what remarks I needed to make. And of course, we want to remind you that we will be having the next such workshop for our African chapter, and this will be on the 3rd and 4th of August. 3rd and 4th of August are the dates that we have tentatively decided. We will confirm everything with our partners in IOFS also before finalizing it. And then again, the last one, the 3rd such workshop will be for the region of the Middle East, North Africa. And finally, we have on our plans to have a conference based on all the discussions and the needs which have been expressed, will be expressed also in this workshop and the other 2 workshops. So they'll be followed by a conference maybe at the end of the year or early next year. So that's all that I have to say. Back to you if you want to have any final comments.
Well, we conducted a poll in the start of the webinar. So according to that, we had about 40 plus participants that took part into the polls, and most of them were government of related jobs, and almost 50-50%, 40% was gene bank, related to gene bank, and other was researchers, and only 3% from the teaching profession. The regional participation was almost from Asia, as it was meant for Asia, but 6% were from other countries they have joined. Gender was, male was 48% and female participant were 52%. And the interest of crop for those were fruit crops 23%, vegetables 13%, and field crops 58%. So most of the people, they were from the field crops interest. And I think this is all from my side, and I thank you very much for being with us, and I hope that we will meet again in August in the Africa chapter. So thank you very much from our side.
Excuse me. Yeah. On behalf of IOFS, on behalf of Dr. Ismail, first of all, we would like to express our gratitude, respect to our partners, Comstech and BCI. Thank you so much for this well-organized training. And also the big thank to all the resource persons, speakers, with their very outstanding and informative presentations. They were very, we got so much of information and experience, the practices from Turkey, from Tunisia, from Pakistan especially. It was very informative. Thank you so much. And just to remind our participants that first of all, this joint training was conducted just for, first of all, for the strengthening the network of our genetic resources experts, and also it is like part of the capacity building to member countries. Thank you so much, and hope to get all the questionnaires, and then all presentations will be also distributed accordingly. Thank you so much, Dr. Khurshid. Thank you so much, Dr. Sadaraddin.
Yes. Thank you so much. Looking forward to see you soon. Bye.
Bye-bye.
Bye.